Today I'm launching my beginner course called iOS Dev Launchpad. Now, I wanted my beginner course to be different, right? Because I know there's a lot of beginner courses out there. And of course, we're gonna do the basics of the Swift language. We're gonna learn all about Xcode. We're gonna build a couple beginner apps. Like, of course, we're going to do that. But my idea or my goal, my mindset, whatever you want to call it, for this course was to be like, imagine if you had a really good friend who was an experienced iOS developer, and you went up to them and you were like, "Hey, friend, I want to be an iOS developer too. Can you teach me? Can you show me the ropes?" So when I built this course, I built it through that lens. And that's why, yeah, again, of course, we're going to do the code, build the apps, of course, but we're also going to talk about like the world of iOS development. And that includes things like the various career paths you can take, the pros and cons of each, things like what are third-party libraries, like what is version control, how do apps even work with like the server and the client, and like what is an API. We're also talking about how to network as a developer. What are blogs you should be following? What are recommended podcasts, recommended books? Because I know what it's like to start something like this. You're just a ball of excitement and enthusiasm. And my goal with this course is to point that enthusiasm rocket in the right direction so that your journey is a lot smoother, right? Give you a great foundation, point you in the right direction, and you're good to go. So that's the overall idea for the course. Now let's talk about some details in what you're going to be learning. First of all, who is this course for? I built this course in mind for the absolute beginner. Like, we start from the beginning, how to download Xcode. This is what a variable is. This is what the Swift language even is. Like, we start from the very beginning. That being said, if you're still early in your journey, like, there's almost 60 videos in this course. So I'm confident that even if you're past that absolute beginner, but you're still early, I'm confident you'll still get value from this course. But again, I designed it so that you could easily pass this off as somebody's very first steps into this world, right? Again, like, you have a friend that says, "Hey, I want to learn that too." Like, this is the content you give them. And because this is meant for absolute beginners or those that are very early in their journey, I keep things at a high level. This course is all about just exposing you to this world and building that foundation, because this is the first step among many. But also because, again, I remember what that was like. This is how I learned, by doing online courses, YouTube videos. This is how I started my career. So I remember being completely overwhelmed. So there's a lot of topics that I could have gone deeper into and given you a ton of information. But what I'm trying to do with this course is walk a fine line between giving you enough information, but not giving you too much to where you're overwhelmed or it's confusing. And you just kind of give up, right? So I'm trying to walk that balance. So I know some of you may say, "Oh, I wish you would have went deeper in that," or maybe in some topics I go too deep for you. But just know that, like I said, I'm trying to walk that balance, because I know what it's like to be overwhelmed. And sometimes getting all the information is more confusing than helpful. Because like I said, this is step one on a long journey for you. Most people that start from scratch to get hired as a professional iOS developer, it can take anywhere from 6 months to 2 years and everything in between. So don't think that you're going to take this course and be ready. Like, this is not how it works, right? This is a long journey, at least 6 months of hardcore learning, likely even longer. So I just want to set those expectations. Another thing I wanted to be sure to include with this course is good service. So I've created a Slack channel that's for all my courses, right? But each course has their own individual room. But this is a Slack channel that you can join and go in and get real-time help, not only from me, but from other students. Like I said, that Slack channel is for all my courses. So you're not just going to get beginner developers in there, you're going to get more experienced developers in there as well. And what I've seen so far is that people have been very helpful in that Slack channel. And I'm very thankful for that, because as thousands of students come into these courses, I just can't answer everybody's questions. So we're trying to build a good community to help each other out in that Slack channel. So be sure to join that. So let's finish up going over the structure of the course. So for about the first 40 to 50% of it, we're going to be going over the basics of the Swift language. Then we move on into building a couple of, basic beginner apps. We're also going to break down one of these apps where we build it the first time using Storyboard and Interface Builder. And the second time, we're going to build it all programmatic UI. So you get a little taste of both. And I also have a little Swift UI preview section talking about what it is, why this is a very different way of doing things, and then we build like a little sample screen with it. But the reason this whole course doesn't focus on Swift UI is because, it was just announced in summer of 2019. It's still very early. It's going to take a long time for, major apps to adopt it. It will have its day, but it's still very early. So again, if you're trying to get a job in the next 6 months to 2 years, UIKit is still going to be very, very dominant. But we give you a little taste of Swift UI here. And then we move on to kind of like the general programming knowledge section, talking about, how apps work, the server, the client, what is an API, what are third-party libraries, how does version control work. We talk about different career paths. And then I start recommending some resources. Again, podcasts, blogs, websites, videos, books. Again, I want to set you up for future learning because this is the very first step in your journey. A little over 5 years ago, I was just like you. I was trying to learn how to code just by watching online videos, taking online courses. And I wrote my first line of code at 32 years old, had no prior programming experience, just wanted to do a career change and was interested in this. And I wanted to create a quick video in this beginner course going over my story, just to show that, again, I didn't start coding till I was 32. I had no prior programming experience, and I've done very well for myself. And I don't say that to brag. Again, the point of this video is to show you, somebody that was in your shoes and that has done it. So like I said, I've been an iOS engineer for about 5 years now, just about all of which was spent in San Francisco in Silicon Valley. How I got interested in all this is I was working for a startup out there as a growth lead, sales type stuff. And I just became friends with our engineers because it was a small team, small startup, and started asking questions about what they were doing and just about coding in general. And to be honest with you, and I hope this doesn't come off as arrogant, but after getting to know them and seeing what they did, I was like, I'm just as smart as them. There's no reason I can't do that. So I started exploring, started Googling, doing online videos, YouTube, buying online courses. Again, I was exactly where you are right now. So when I started learning, it was early 2015. By summer of 2015, I did an iOS developer bootcamp. Now I know what you may be thinking. Well, bootcamp is great. That's what gave you that head start. But now that I've done the bootcamp and I've created tutorials, you just learn the very basics in the bootcamp. Like everything I learned in the bootcamp is in super beginner online YouTube videos, right? The benefit of the bootcamp for me was forcing myself to work on it for 8 hours a day, right? Because you got to be there for 2 months, 8 hours. So that was the huge benefit of the bootcamp. Not I got crazy good knowledge or crazy good teachers. It just forced me to do it. But my bootcamp was a good experience. I liked the people I graduated with. We ended up building an app called Fit Hero, which I really, really like. You're seeing some screens of that. Thought it was pretty cool. And about a month and a half after the bootcamp, I got hired at my first real iOS developer job. So now we're talking November 2015 at a company called Breathometer. They were on Shark Tank. They were the first company to get all 5 sharks to invest. I think they got $1 million investment. This was back in 2013. That was a pretty big deal for the time. But I got that job not for my developer skills, and I'll tell a quick story. So I basically did the phone screen interview, failed miserably, did horrible. And I found out later, they're like, yeah, we put you in the no pile, we were already moving on. But what I did was I showed a little bit of initiative. I emailed them and said, hey, look, I know I didn't do well on that. Do you have a take-home project that I could do, something I could work on that I can really showcase my skills? Because I know as somebody without a CS degree and just a bootcamp grad, I know I have to prove myself even more. So I would love to do a take-home project and show you what I can do. That was basically the email. And they said, sure. And long story short, I did the project, they loved it, and I got hired. So I guess the tip there is don't be afraid to show some initiative. But anyway, I got hired there, again, in San Francisco, and I was making $60,000, which again, when you talk about salary, that is different all over the world. I get it. But for San Francisco, right, Silicon Valley, $60,000 for an engineer is well below minimum wage. But I took it because, again, I had applied to 60 companies. I wasn't getting any jobs. It was rough getting that first job. So I was like, I just need somebody to take a chance on me. I know I can get in there, prove myself, and I'll ask for a raise in 6 months. That was my plan. Because I knew I would get in there and perform. I had confidence in myself. And within a month and a half of working there, my VP of software, my boss, kind of pulled me aside and was like, I'm working on a raise for you. You deserve it. We need to pay you the just market rate. It wasn't like I was getting superstar money, but just market rate, because 60,000 was not market rate. Long story short, a Series A funding, delayed it and delayed it and delayed it. Anyway, I ended up getting $100K by May of 2016. So I'm 6 months in to my first ever job, and I crossed the 6-figure mark. And again, I don't say this to brag. I say this to just let you know what's possible. So I worked at Breathometer for about 1.5 years, and then I left there to start interviewing at some of the major companies in Silicon Valley, right? The Facebooks, the Apples, the Googles. Naively, I thought I was ready, right? After just 1.5 years of basically on-the-job training, I thought I was ready. So I went out and did all those interviews. I got my butt kicked. Basically just failed all those interviews. It was a great experience, and I did get interviews at all these companies, but when I got to a final interview or a whiteboarding session, I got my butt kicked. But it was a good rude awakening, and it actually led to the creation of my YouTube channel that many of you are probably familiar with, because I wanted to show my knowledge. Rather than wait on an interview, I wanted to just put all my knowledge out there by making videos, become a well-known name in the space, and that was kind of the whole point of the YouTube channel. But during this time of me getting my butt kicked at interviews, I picked up some contracts on the side because I had quit Berthometer. I wasn't working. I was focused solely on interviews. And as I'm getting my butt kicked in the interviews, I started picking up more and more contracts and was like, you know what? Let me try contracting, right? I got enough to support me. So for the next year and a half, I did independent contracting, which was great. I say that was like the time where I learned the most, because in independent contracting, I bounced around from project to project like every 3 or 4 months. So I got a lot of experience and a lot of exposure to different code bases, different types of apps, etc. So that's when my learning really skyrocketed. And again, at that point, I'm already a year and a half into my career before my learning skyrocketed. So just keep that in mind. So after working remotely by myself for about a year and a half, quite frankly, I started getting bored and lonely. Like I never left my apartment. So I was yearning to get back on a team. So in April of 2018, I joined Aluna, which was great because I got the opportunity to build a product and build the app from scratch. And it had like a video game element to it. So it was kind of building like, the economy of the game. Should we implement daily quests? So that was a ton of fun. And I worked there full time up until July of 2019. I'm still there to this day in more of a part-time consultancy role because I'm there to like help them make sure the app launches correctly and smoothly, but I'm not there full time anymore. Now I left Aluna back in July of 2019 because I wanted to do one of two things, right? I was kind of at like a crossroads in my career. Because I'd spent all my time either independent contracting or at small startups, I never got that experience at a big company like the Googles, the Facebooks, Apples, etc. So I really thought I wanted that on my resume. And it's not that I wanted to work at a big company, like I wanted the clout, the prestige, if you will, of having that on my resume so that could potentially open up doors for my future. So looking back on it, I kind of wanted to work there for the wrong reasons. Long story short, I could either go big company or pursue this YouTube thing full time because I've been building this YouTube channel, at this time for like 2.5 years. It was growing well. I could see the business opportunity there. So my choice was big company, do my own thing. And I was actually in pretty serious talks with PayPal. I was in the interview process with Twitch. And right in the middle of all that, I decided I'm going to pursue my own thing and do this YouTube thing full time. So that was back in August of 2019. I made the full-time leap and here we are, right? The YouTube channel is going very well. I'm putting out courses for the community, creating all kinds of content for the community. I'm very happy with my decision, right? I work for myself. I get to work on fun projects, whatever I think will help my YouTube business. It's just a blast. So I was able to take this skill that I learned, this iOS development, building products, and parlay that over 5 years into now working for myself. Again, the biggest benefit of that is I get to work on what I want to work on, right? If I have a cool idea, I work on it. And as of March of 2020, it has already surpassed my Silicon Valley developer salary, and we're still just getting started. So I don't say that to brag. I wanted to share my story just to show you how great this career is and this skill is and all the flexibility and the things you can do. Like the multiple career paths you can take with this skill, it's just amazing. In fact, I got a whole video later in the course talking about all the different paths you can take to really, fit your lifestyle. So that's my story. And again, I wanted to share that to hopefully inspire you. Of course, you're not going to follow my path directly. You're going to create your own path. But the beauty is you have so many options. That path can take you so many different places. So let's just get on to learning this stuff. Before we can actually start writing Swift code and building apps, we need the tool to do it, and that's Xcode. Xcode is a IDE, or Integrated Development Environment, which basically just means it's a software program for you to write your code. And Xcode is Apple's first-party IDE that allows you to write code for Apple's platforms, right? iOS, macOS, watchOS, etc. And the great thing about this being Apple's first-party program is that it's updated constantly. The typical release cycle, like for example, we're on Xcode 11 right now in March of 2020. But every June, the next Xcode gets announced. So Xcode 12 will get announced at WWDC this year and will be officially released, in the fall. But again, it does get updated periodically throughout the year with like Xcode 11.1, 11.2, and so forth. And here on the screen is just what Xcode looks like in a typical project. The project we're looking at right now is the code for my take-home course, and I usually have 2 files of code side by side. And if this looks a little small, that's because usually when I do a tutorial or a course, I have my font and my screen resolution blown up so it's easier for you to see. But typically when I code, it is pretty small like this. So now that you have the general idea of what Xcode even is, let's talk about downloading it. First and foremost, you're going to need a Mac, whether that's a MacBook or an iMac. You're going to need one of those because Xcode is meant to run on Mac OS. Now, of course, with anything with computing, there are hacky ways to get it to run on a PC, but that's not recommended. To download Xcode on your Mac, go ahead and open up the App Store. Now, down in the lower left, you should see your name, hopefully. That's if you already have an Apple ID. Now, again, if you already have an iPhone and a Mac, you probably have set up your Apple ID a long time ago, but just in case you haven't, go ahead and click sign in and you have to create your own Apple ID there. If you're already signed in, you're good to go. In the upper left here, type in Xcode into the search and you'll see it pop up. Click on Xcode to open up the detail page to, see a little bit more about it. Now, as you can see down here, it is 7.8 gigabytes download. So it is a very large file. So make sure you have enough space for it. And make sure you got about a half hour to download it, depending on your download speeds. After it's finished downloading, you should see it in your applications folder. Go ahead and double click on it to open it up and you'll see this quick little menu screen. Now, as you can see, there's 2 paths we can take. We can create a new project or create a new playground. We'll start with a project. So opening up a project is a full-fledged, app, whether that's an iPhone app, Mac OS app, watch app, whatever. That's a full-blown app. Now, however, you may we just want to play around in some code. As a matter of fact, that's what we're going to do in much of the first half of this course when I'm just explaining the basics. That's where you would open up a playground. Playground's aptly named, right? It's for you to just go in there, play around for a little bit. Think of it as kind of like a scratch pad for your code if you just want to try something out. But it can go above and beyond that. Like you can even prototype UI in a playground, and then once you got the UI tweaked the way you want it, you can just copy and paste that code into your project. So playgrounds are insanely valuable. So like I said, in this course, we're going to start with playgrounds, but once we start building apps later on, we are going to shift into projects where Xcode gets a little more complicated. And don't worry, when that time comes, I have some separate videos giving a tour of Xcode, how to use it. We'll dive into more detail on Xcode then, but I don't want to teach it to you now and have you forget it by the time we actually use it. So we'll push that off till later. But there's one thing I want to show you right now because it will affect the playground is your Xcode theme. Many of you that just opened up Xcode for the first time, you're looking at my Xcode, which has a black background, bright colors. Yours may have a white background, and you're like, wait a minute, how do I customize that? How do I get my Xcode to look like yours? Well, let me show you. So back in the main Xcode menu, go ahead and hit create a new Xcode project. Now see, you'll get a bunch of options here, right? WatchOS, tvOS, etc. Just open up iOS. This is just a test app. We're not really getting into it. You can call it test. We're going to delete this later. You can fill out the rest of this based on my information that I have here. Make sure you have Swift selected and Storyboard selected, not Swift UI. More on that later. Again, I'm skimming over this because we're just opening up a quick test project. We will go more in depth later on in the course. So hit next and then save it to wherever you like. I'm going to save it to my desktop. We'll replace it. I already have a test one because I do this a lot. Maybe you don't. So what I want to show you here again is Xcode and then preferences. So actually, let me get some code up here. Let me go to View Controller to get some code on the screen, and then Xcode Preferences. And you see here, I already have it selected. Fonts and colors. If you don't, that's where you want to go. And then you can see this theme here on the left. You probably have it on Basic, which is a blinding white. Like only psychopaths use light mode, like use dark mode. Jokes, of course. But you can see a bunch of different themes, like Civic. I'm just going to, page down through these so you can see all the different themes you can choose. So pick whichever one you like. Again, I was joking. Maybe you do like the light background. Maybe you like this yellow background. But I choose Midnight. And then once you choose your theme, you can actually pick each individual aspect of that theme and customize that even further, down to the font and the color. For example, this comments by default is this same green that you see here. I like my comments, as you can see over here on the left, I like my comments to kind of fade into the background. I don't like them to be, overbearing because I like my code to actually pop, just my personal preference. So what I did was I clicked on comments, and then you can click next to the font here. You can see the color wheel will pop up, and then you can pick whatever color you want. So keep an eye on my comments here in the upper left. Like, look, I have them blue. We'll have it dark. Right? They can be blue, they can be green, yellow, red. You can make it whatever you want. Again, I I like them to just be gray so they fade into the background and not be too overbearing. So again, if you want to play with your theme to get it to look right or look like mine, this is how it's done. Have a ball, customize it the way you like, but this will affect your playgrounds that we'll get into in the next videos. Let's take a second to talk about UIKit versus SwiftUI. So UIKit is what we've used to build our user interfaces in iOS development pretty much since it came out. And SwiftUI seems to be this new direction that Apple's going for all of its future development. Now, we first even heard about SwiftUI in the summer of 2019, and it finally just came out of beta in fall of 2019, but it is still extremely early in its development. So you, as somebody just starting out in iOS development, you're probably asking, what should I learn? Should I focus on UIKit or should I focus on SwiftUI, right? Because if SwiftUI is going to be the future, like I want to focus on where Apple's going, not where it's been. And that makes sense. I get what you're saying, but let's talk about that for a second. The bottom line is with SwiftUI, again, it's super early in its development. It's not going to be relevant in the job market for a couple years. And by relevant, I'm not saying there's going to be no SwiftUI jobs. I'm saying that like a large chunk of jobs will be SwiftUI. And I think that's still 2, 3, 4 years away. And the typical time frame it takes for someone like you who's just learning iOS development to get that very first job, that can take 6 months to 18 months to even 2 years, right? Like that's the typical time frame. So this course is coming out in March of 2020. I would say 2 years from now, SwiftUI will just be starting to kind of hit its stride. But let's think about this for a second. The App Store has been out for 10 years. And the way we've made apps up till now is with UIKit. So that is millions of iOS apps built in UIKit. But even next year, 2, 3, 4 years from now, when you're out in the job market, there's still an extremely high likelihood that the app you get hired for will be either all UIKit or still have a lot of UIKit. So the bottom line is, you're asking yourself, which one should I learn, UIKit or SwiftUI? You're going to have to know both. So in this course, we focus on UIKit for the most part, but I do have 2 videos towards the end of the course where I talk about, what SwiftUI even is, the paradigm shift, how it's different from UIKit, some of the benefits you get from SwiftUI, and then we're going to build a pretty basic screen in SwiftUI so you can get like a taste of how it works. But again, the entire goal of this course is to expose you to this world, give you that foundation of knowledge, so when you want to take your knowledge even further down one of these paths, you're doing it from a good foundation. So to sum that up real quick, you're going to have to learn both because we're way too early in SwiftUI's development for it to be relevant in the job market. And like I said, most of you watching this are going to be in the job market within a year. SwiftUI won't quite be ready. And even so, millions of apps are already in UIKit. So you're going to have to know that. It's going to be hard to avoid. So unfortunately, the answer is you got to learn both. And we're going to expose you to that in this course. All right, here's the updated October 2021 opinion on UIKit versus SwiftUI. Now, I left the old video in, maybe you just watched that, just to show the evolution of the thinking as time goes on, because that's been about a year and a half since I recorded that one. And I said back then, in 2 years, maybe SwiftUI would be hitting its stride. And I do believe that's true with iOS 15. SwiftUI continues to grow and mature, and I think it's getting there. I think it's almost there. Not quite there yet, but it's really getting there. But aside from functionality and the ability to build a great app in SwiftUI, let's talk about job market relevance, because UIKit still dominates, I don't know the exact percentages, but it crushes it, right? Very small percentage of jobs are in SwiftUI relative to UIKit still, even as of October 2021. But it's starting to change. You're starting to see SwiftUI jobs pop up more and more. In fact, just last summer, I hired 2 iOS devs for a project that was completely SwiftUI. So again, you're starting to see it, slowly gain steam. But to be clear, UIKit still dominates as of right now. So my recommendation, if you're just watching iOS Dev Launchpad for the first time in October 2021 or later, you're just getting started, the recommendation on which to learn, which to focus on, I would still say you need to learn both, but again, SwiftUI is picking up steam. For example, in the old video, March of 2020, if you were going to focus all in on SwiftUI back then, I would have said that was a mistake. It's way too early. However, as of October 2021, I still think you need to learn both, but if someone came up to me and said, you know what, I'm going all in on SwiftUI, this is where Apple's going, right? The classic Wayne Gretzky saying, skate to where the puck is going, not to where it's been. I probably couldn't fault you for that. Because again, the process of going on this journey of becoming an iOS developer typically takes 6 months to 2 years. So if you won't even hit the job market for 6 months to even 2 more years from now, yeah, I think SwiftUI is gonna look a lot better. However, I would want to set your expectations that UIKit will still probably be dominant, so you are going to be limiting your job prospects, but it still may be the right move for the future. Quick example, that's what I did with Swift. Swift came out in 2014. It's about the time I started learning. And to be honest with you, Swift is what got me into iOS development. And I said that day, because it was the same situation, Objective-C was still dominant. No jobs were in Swift. But I said that. I was like, you know what? It's going to take me 2-3 years to be really good at this. So again, I want to go to where Apple's going. So I went all in on Swift, knowing that would limit my job prospects because Objective-C was everywhere. But, I worked at it for a year or so and finally got that Swift job. And I've been focused on Swift day one. And I think that was a good move. Here we are, 6-7 years later, and I've been writing Swift pretty much 100% from day one. So that has benefited me. So I think at this point in time, if you were to go all in on Swift UI, I think a similar thing might happen there. So again, to be clear, UIKit is still dominant as of now. It will still be dominant a year from now. But if you were to go all in on Swift UI, I couldn't fault you as long as you set your expectations. That it may be a little harder to find a job, but if you can find one, it'll really benefit you that you kind of made that gamble, that leap on Swift UI early. So there you go. That's the updated opinion. To sum it up, you still need to learn both. UIKit's still going to be dominant for a couple more years. But for those of you that like to be a little risky, like to take chances, I wouldn't fault you for going all in on Swift UI. But if you are more conservative, you are worried about landing a job right away, maybe you should focus on UIKit. Before we actually start writing Swift code, let's talk about what Swift is and give you a brief history, right? It's good to know what's going on with the language before you start learning. So Swift is relatively new. It was a surprise announcement at WWDC back in 2014. Like, developers had no clue it was coming. They're watching the announcements and it's like, holy crap, a whole new language? Like, everything changed back in 2014 when Swift was announced. What the engineers at Apple did was they took all their previous knowledge with Objective-C and everything, because Objective-C is 30 years old, and they did all their research on the new and modern languages and where things were going, and they took all that and they built Swift, Apple's next generation programming language that is for their future. Now, a lot of people always ask me, because native iOS development, admittedly, it is a niche programming language. It's not as widespread as, Java or JavaScript or Python, but it is niche. So a lot of people ask me, like, if I become an iOS developer, like, does that limit my career choices? And I always say, like, as a Swift developer, iOS developer, whatever you want to call it, you're tying your career to Apple. And as long as you believe that Apple's not going anywhere and it's going to be around for a long time, into AR, VR, whatever direction they go, I think that's a pretty safe bet. Speaking of safety, amazing segue, one of Swift's major selling points is it's just a safe language. There's type safety, objects, can't be nil unless you use optional. Basically, a big thing of Swift is you want to have a lot of compile time errors, not runtime errors. As a new programmer, newly aspiring programmer, that may have meant nothing to you. Basically, what that means is Swift tends to give you errors at the time of writing your code or when the code compiles in Xcode, whereas runtime errors are you don't know about the error until the app crashes, and then you got to debug. So you're going to see a lot of compile time errors before you can even build your app with Swift. Let's run through Swift's very brief history. Again, it was announced in 2014, just to let you know kind of how Swift has evolved over the past couple years. Now, Swift had some massive changes and very rapidly in its early days. And the reason you should know this as a new beginning Swift developer is because if you look for a blog post or maybe a Stack Overflow answer or some resource that is old and hasn't been updated since, 2015, 2016, that can get you in a lot of trouble. Because again, through 2014, 15, 16, 17, Swift has changed a lot. But the good news is that change is starting to slow and Swift is slowly starting to mature. All right, back to the beginning. Like I said before, it was a surprise announcement in 2014. By 2015, Swift 2.0 was announced, and it was also announced at WWDC in 2015 that Swift was going to go open source later that year. It ended up going open source in Swift 2.2 later, like in December of 2015. Now, open source was a big deal because that meant the iOS developer community as a whole could contribute to Swift language itself. If you ever want to look into this, go to swift.org. You can see the forums and see the discussions on proposals that are going to be implemented into Swift. Now, don't get me wrong, this is like heavy language implementation details. Most of it's even over my head. But if you are interested in like how the language gets built or, what new things are coming to the language, that's the spot to go look. Now, going open source was a big deal. But in 2016, Swift 3 came out, and that was a huge deal. That was dubbed the Great Renaming. Basically what happened between Swift 2 and Swift 3 was a ton of breaking changes in Swift's API. So it was a nightmare converting a Swift 2 codebase to a Swift 3 codebase because so much broke and so much changed. However, Swift 2 to Swift 3 was kind of like just ripping off the Band-Aid, right? It was a ton of pain right there, but Swift 3 to Swift 4, Swift 4 to Swift 5, and upcoming Swift 5 to Swift 6 have been a breeze compared to that. So they kind of got all the pain out of the way going from Swift 2 to Swift 3. So again, when you're looking at old resources or old blog posts, if it was done in Swift 2, stay away from it. But like I said, after that major Swift 3 pain, it's been smooth sailing since then. Swift 4 came out in 2017, but Swift 4 kind of was the last major number release at WWDC. Up until Swift 4, again, every dub, which was June of every year, we would get a new Swift 3, Swift 4. Well, they've kind of slowed down since then, and WWDC 2018 was Swift 4.2. It has slowed down, and they recently announced on the roadmap to Swift 6 that, there's no major year release. It's just going to release when it's ready, which is great. I love that because it almost felt like they were rushing features into the language to make the annual release cycle. And, they've kind of learned and said, you know what, Swift 6 will release when it's ready, no release date, it'll come. Again, that along with the fact that, the changes coming aren't major breaking changes shows that the language is maturing. And because the language is maturing, we're starting to see it leak out into non-Apple native platforms. For example, machine learning at Google via TensorFlow, that is done in Swift now. That's in part to Chris Lattner, who is one of the main developers behind creating and launching Swift at Apple. He had left for Google and brought Swift over to TensorFlow. He has since left Google as well, just recently, but he was spearheading Swift at Google as well. So it got a good foundation over there. And now you can also write server code in Swift. Swift is almost ready for Windows. That's being actively worked on. But again, Swift is such a young language that, it may not be on all these other platforms yet, but you can start to see the beginnings of it. And if you kind of fast forward your mind 5 to 10 years, it's looking pretty good. Now we're about to go into a bunch of videos about the basics of the Swift language. I want to reiterate that these are just high-level videos, right? A lot of these topics could be almost whole courses in and of themselves, or at least multiple 10, 15-minute videos. Again, like I said before, this is supposed to be your first video, just your exposure to this world. So again, these topics will be pretty high level, but it is a good foundation for your future learning. Speaking of future learning, I want to recommend a couple of resources for you to check out to, again, just expand your world of Swift. First is the Swift Programming Language book directly from Apple. A little bit of a warning, and we're going to talk about this later in the books video, but this is basically Apple's instruction booklet for Swift. So it is pretty technical. I remember reading it as somebody who had never coded before and just started my Swift journey, which may be exactly where some of you are at. It was way over my head, but it is a very valuable piece of information. So I do recommend at least checking it out. But again, don't get discouraged if you don't get any of it. It's a pretty technical book for beginners. What is geared towards beginners is the Swift Playgrounds app. And I definitely recommend downloading that. It's free to download. It came out a couple years ago, and it's being actively maintained. Like every year or so, you'll see a pretty big update to the app that adds a bunch of new features. So that app is still growing, but that's a great way to get started and play around as well. They do a good job of gamifying things. And in the description of this video, I'm going to leave 2 more links. One is to the actual Swift website page if you want to check that out for another big overview. And then another is a pretty fun video about the reveal of Swift at WWDC in 2014. And you can hear the gasps in the audience. It's pretty cool to go back and watch. So that's a brief history of Swift. Let's start writing some code. Let's talk about a foundational concept in Swift, and that is types. What is a type? It's what type something is. Great explanation, I know. Let me show you and that'll make more sense. In this example, we're talking about the type int, which is short for integer, which is a whole number. Now it can be negative, but an example of that is, let's say you have a high score in a video game. So we're going to create a variable called high score. It is of type int and it equals 0, right? We're not very good at the game. But the type is int. So what we're saying is this 0 is an integer. Now in Swift, there's tons of different types. We're going to talk about the foundational ones in this video, but the general idea is that our variable high score is of type int and it is equal to 0, which 0 is an integer. Let's build upon that numerical example and talk about our next two types, and that is float and double. Whereas if integer was a whole number, float and doubles are decimals. Now the main difference you need to know between float and double is the amount of decimal places, or the precision. A double has a precision of at least 15 decimal places, so pretty long, whereas a float has a precision of at least 6 decimal places. So as you can tell, a double is more precise than a float. And now with these floats and doubles, you don't have to use all these decimal places. That's just their capabilities. As you'll see in this example of a percentage complete, like we want 76%, so we'll just do 0.76, right? You don't have to use all those decimals. 0.76 gets the message across. But to reiterate, here we have our variable called percentage complete, and that is of type double, and it equals 0.76. Moving away from our numerical examples, we have string. Now a string represents text, and in declaring a string, you put it in quotation marks like you see here. Let's look at an example. We'll create a variable called user's thoughts, and that is going to equal, I hope this course is good, right? So that is a string. Another example could be, my name equals Sean, as you see here. So that is of type string. And finally, we have our bool type, which is short for Boolean, and that is just true or false. In the example here, you can see we have our variable is dark mode on, and that equals true. I know I ran through these quickly, but this is the foundational knowledge that we're going to use and explain throughout the entire course. So you're going to have plenty of time to reinforce this knowledge. But I want to leave you with two pieces of information before we leave the video on types, and that is that, like I said, there are tons of different types throughout Swift, and often we even create our own types when we create classes. So let's say we create a class that is a person, right? You can see Sean is of type person, and then you create that person object. More on that later in the course, but that's just an example of how it doesn't always have to be an int, a Boolean, right? You can create your own custom types. And then lastly, a big feature of Swift is type inference, right? So back to our high score example. If I do var high score equals 0, Swift is smart enough to know that because I put a 0 there, not 0.76 or 1.89, it's a 0, Swift is smart enough to infer that, okay, this is an int or an integer. We don't need to declare the type. And I would say 95% of the time, type inference will work perfectly fine. There's a small subset of time where you will have to manually declare your type. But again, type inference works most of the time. So in future lessons or videos, if you don't see me declare the type after my variable, again, var my name is of type string equals Sean. If I just remove the is of type string, that's type inference at work. So hopefully that avoids confusion. But again, that's the basic knowledge of types. We're going to use this all throughout the course, so you'll have plenty of practice with it. Variables and constants. We got a little bit of a sneak peek in this in the previous video when I was showing you how to use types and I was declaring variables. So you may have a little bit of an idea, but let's dive into that a little further. What variables and constants do is they capture a value so you can use that value throughout your code base. Right back to the previous example talking about integers when we said var high score of type int equals 0, we're capturing the value of 0 and now it's in a variable called high score. Now we can use high score throughout our code base. So again, the fundamental knowledge is variables and constants capture a value. Now, what's the difference between a variable and a constant? Well, a variable has the ability to be mutated or changed, whereas a constant cannot be mutated or changed. And there's some pros and cons to both, right? So if you make something a constant, it's a little bit of a safety feature to where you can't accidentally change it when you don't mean to. Xcode will yell at you. And then also there's a little bit of a performance optimization because Xcode, if something can be changed, it has to allot for that possibility. Whereas with a constant, you say, no, this is the value. It is not changing. Xcode can optimize that and your code can run faster. Now in this first lesson, I'm going to show you how to open up a playground and set everything up. But on future lessons, we're just going to skip this step. So here, get started with a playground. Click on that. Let's start with a blank one. So hit next. And I'm going to name it beg-variables. And I'm prefixing all my stuff with beg because that's how I'm organizing my files all around the beginner course. You can name it whatever you like. And I'm saving that to my desktop for now. And let's make Xcode fill up the whole screen for you. There we go. And your playgrounds will automatically start with a variable that says hello playground. That's a string. Remember we talked about this in the previous video. So just a real quick example. This is a variable called str that is type inference to be type string because Xcode knows this is a string. All your playgrounds automatically start with that. Let's delete this. Don't get ahead of me, Xcode. All right, so let's talk about variables versus constants. Let's continue with that high score example. So var high score equals 0. And again, type inference on the end. I don't have to say it. So now I can actually change high score. So I can say high score equals 55, right? I can update my high score. I did really good on the game, updated my high score. The reason I can change that is because we declared it with a var, so it's a variable. Now, if I made this a let, which is a constant, so if you want to declare a constant instead of var, you do let. Now, if I run it, you'll see it's going to say, cannot assign to value, high score is a let constant. So, but like I said, if it's a let, Xcode will say, no, you can't change this. If it's a var, you can change it. And real quick, just to avoid any potential confusion, when developers are discussing code, and you may hear me say this throughout the course, is oftentimes they'll just call these all variables, whether it's a let or a var. You may not distinguish between the two, right? Oftentimes you just say, create a variable for that and do this with it. And that's because when discussing code, you may not know all the specific implementation details, if it needs to be a let or a var. So if I say, hey, we're going to declare a variable here, I'm not always saying it has to be var, right? It could be let. So variable is kind of like the overarching, way to refer to it. And then deeper, the difference between let and var depends on your implementation details. So again, to avoid any future confusion, if I call something a variable, but I make it a let, that's why. But again, the textbook answer, right? So somebody could come up and correct you because technically they would be correct. You should call it a constant or a variable. But again, oftentimes in just common conversation, we just call them variables. So hopefully that avoids future confusion. All right, let's change this back to var and let's give 2 more examples to just really drive this point home. So something like a name of a person, right? You don't want to change that. So you would do something like let my name equals, and this is a string here, Sean. So now I can't just do my name equals, Joe, right? It'll yell at me, right? Because my name is a let. Cannot assign value to my name. It is a let constant. But something, let's delete this, more along the lines of, var current active users, right? That's something that is always fluctuating. We'll say that equals 124. Now I can change and update that, right? Like say I get a huge spike in traffic on my app. I can, say, okay, we need to set current active users equal to 1,458, right? And that can be changed because that is a var. And to reinforce the core concept of variables and constants, they capture a value. So you can use that value, for example, this current active users value, I can use that throughout my code base. For example, if current active users is less than 4, print out traffic is way down, right? I can do stuff like that based on the value that's captured in this variable. Now let's talk about arrays. An array is a container or a list of objects. Here on the screen is a visual aid to hopefully help you understand the concept of an array. For example, this would be an array called fruits. As you can see, there's various different fruits in this list. Now, one key thing to know about arrays is that this list is numbered, but as you noticed, it's 0 indexed. What that means is the count starts at 0. So the first item is not 1, it's 0, right? As you can see, 0, 1, 2, 3, 4, 5, not 1, 2, 3, 4, 5. Real quick, take a second to let that sink in because I guarantee you're going to have an error because you forgot this at some point early in your career. So this is very important. It's a fundamental thing to know about arrays. Now, of course, arrays don't always have to be fruit, right? We can have an array of integers, right? Let's say we want to call this ages, and this represents the age of everybody currently taking this course. Another thing to know about arrays is that they're always in order. Now, by in order, I don't mean alphabetical. I don't mean numerical, as you can see with these different ages, right? I mean the order that they were put into the array. Let's illustrate that and a lot of other things you can do with an array in some code. Here I am in a brand new playground. Remember last video I said I wasn't going to go through the step every time of like file new playground and naming it. So go ahead and do that on your own and you'll see this empty playground to start with. All right, so let's create that array. So var ages equals, and it's an array of, let's say, the different ages, 21, comma space 55, comma 19. I'm just going to put in like 8 of these real quick, just random numbers and whatever, 71, that's it. I think there's 8 of these in here? Cool. Now, real quick, we just declared this array, and what I talked about was the order that I put them in. So, I put in 21 first, then 55, then 19. That's what I meant, that they will always be in order. Again, not numerical order. And again, back to type inference, ages knows that it is an array of ints because I've put all ints in here. Now, however, let's cut these. I'm going to do Command X to get rid of them because I'm going to paste them back in, so I don't have to type them again. Now I have an empty array, but you'll see Xcode is saying empty collection literal requires an explicit type. when I had all integers in there, Xcode knew, all right, ages is an array of ints, but I don't have anything in there, so it doesn't know. When you want an empty array, which is actually quite common, very often you'll declare an empty array, but if you do that, you have to give it a type, and you have to put the type in the brackets to let it know it's an array. So this is saying ages is an array of type ints. So that way, even if you declare an empty array, Xcode knows, hey, I'm expecting an array of ints. And then later on, if you try to put in a string or a Boolean, Xcode's gonna be like, no, can't do that. This is an array of ints. But let's put those ages back in there and we can delete our type declaration because we don't need that. We'll use the type inference. Now let's talk about some of the features of an array and how you can use it. So first up, we can always get the count of an array by doing ages.count. And this gives you the number of items in the array. So if I hit this little play button on the left to run it, you'll see on the right, we printed out 8. So that means there's 8 items in this array. And you can count it for yourself. There are in fact 8 ages in there. Another common thing you want to do with arrays is access the elements that are in there. For example, you can do ages.first, and this will return the first item in this array. 21. You can see it print out 21 here. 21 is the first age. Same thing, you can do ages.last. Same thing. Now it's going to give me 71, right? As you can see right there, because that is the last element of the array. Now, real quick, a little sneak peek into optionals. You'll notice ages.last was an optional. This question mark means it's an optional. We're going to dive into that later. I'm not going to get into that now because we're just starting out. But the reason it returns an optional is because ages could be an empty array. And if you have an empty array, what's the last object in an empty array? Like nothing. So you don't want the app to crash. So that means it returns an optional, which means it can be nil. Again, if that was confusing, you don't know what I'm talking about, we're going to discuss that in a later video. But I wanted to explain to you what this little question mark meant. That basically meant that like this can be nil. This can have no value. And again, in the case of an empty array, there's no last object in an empty array. All right, more accessing items in the array. So we did first, we did last. What if you want one in between? Well, you can do ages, and this is called subscripting. We do brackets and then put in a 0. This is where you put in the index number. So ages at index 0 is going to be 21. So it's going to be the same as first because we did index 0. You see it prints off 21 there. But you can also do, the fourth one if you want for 3. Remember, 0 indexed. So the fourth item is going to be 3 because it goes 0, 1, 2, 3. So now the fourth item is 47. See, it prints off 47. So that is how you can access individual elements in the array. And again, this goes back to the array being ordered. It's always going to be in the order you put it in. That way you can reliably say, give me the item at index 3, and it's always going to be the same. If it was not ordered, item at index 3, it would be different every time. So that is why the array is ordered. Now, aside from accessing items in the array, we can actually manipulate our array. Let's say we got a new student and we wanted to add a new age to the end of it. So I can do ages.append, and you can see new element int. And this is type safety in action, right? Because ages is an array of ints, it's not going to let me put anything other than an int in there. Again, this is the whole safety aspect of the Swift language. So let's say we want to put 99 in there for our new student. Now, a way to print out stuff is to print ages. And if I run it down here in the console at the bottom, it's going to print out my ages. And now you can see 99 is now appended. So the thing when you append stuff is you're appending it to the end of the array. So that's why 99 went there. And let's say you didn't want to append it to the end, you wanted to put it at a specific spot, you can do ages.insert, and you can see new element, which is an int, again, type safety. So let's say we want to put 44 at, and now we're putting an index, right? We want to put it at index, let's say 0. We want to put it at the beginning. So insert 44 at index 0 right at the beginning. Now if I run it, we're going to print ages down here, and now you can see 21 is no longer at the beginning, 44 is at the beginning. And the last 3 things I want to show you is how we can sort our array, how we can reverse our array, and how we can shuffle it, right? So let's do that. So ages.sort, and you can see if we print it, now we're going to get this array in numerical order, right? 19, 21, 22, 37. So sorting an array is as simple as that. And we can do the same thing to reverse our array. So if we do ages.reverse, there you go, and we run it. Now, we didn't do sort anymore, so it's going to reverse what's actually in there on line 3. Or actually, no, we added the 44. So 44 is at the end, 21, 55. You can see it's in reverse order from what we have up here. And then as you may be following along here, we can do shuffle as well. Shuffle. And that will shuffle up all the numbers in the array. So you see we got the array down there, and now it's all shuffled. So those are some basic things you can do with an array. Now, arrays are used so much throughout code and building apps. a very common thing that you may see on a day-to-day basis is maybe your Twitter feed, right? Your Twitter feed that you're scrolling through is an array of tweets. It's just a list of tweets that show up on your screen. And same thing with your Instagram feed. Your Instagram feed is an array of posts that show up on your screen. So arrays are used everywhere. It's a very foundational knowledge. Hope you got that. As always, ask questions in the comments or on the Slack channel. On to the next video. Let's talk about sets. Now, a set is pretty similar to an array in that it is a collection of items. However, there's some key differences between sets and arrays. First up, a set is unordered. If you remember last video, we talked about arrays being ordered and they would always stay in the same order, provided you don't change them. Well, a set cannot guarantee any order. Next, a set cannot have duplicate values. If you remember the array that had all of our ages from the students in the course, well, in an array, we can have duplicate values in there. However, a set can only have one of those values, no duplicates. So you may be thinking, a set is not ordered, I can't have duplicates, like why would I want to use a set? Well, one big advantage to a set over an array is performance and speed. Sets have faster insertion, removal, and lookup. And to illustrate all these points, let's dive into some code. Here I am in an empty playground. Go ahead and create that on your own. To start, we're going to recreate that array, not a set, our array of ages, because we're going to use this as comparison to help really illustrate the differences in a set. So I'm going to throw in a few random ages in here, 18, 33, 55, 17, 94, 20, 26. Okay, cool. Just some random ages. And actually, let's put some duplicates in here just to illustrate that we can have duplicates, space 17. Right? So you see 17 is a duplicate and 33 is a duplicate. That's fine in ages. So again, we're going to use this array to learn about sets. Now to initialize an empty set is a little bit different. So you have to do ages. Let's call this ages set just to be clear here. And for the array, if you remember, we would do this for the array. So we would say it is an array of ints when we were declaring a type. Well, for a set, you got to be a little bit different. You have to say it's a set and then you use angle brackets and you put the type in the angle brackets. So equals that. So now that is an empty set, right? We've declared here, this is a set of type ints. That's if you want it to be empty. You can also initialize a set based on an existing array. So that's what we're going to do down here. So var ages set. Now I can't have two things of the same name. So let's comment this out. You can do command / to comment that out. So ages set. And now we can initialize this based on an array. So we can do set and then we can pass in an array. So we can do ages, right? So you can create a set based on an array that already exists. This ages array already exists up here. Now, if you remember, I said you can't have duplicates and it's unordered. So what we're going to do is we're going to go ahead and print ages set, and then you're going to see that our duplicates aren't in there, right? If you look here, we have 17, 17, 33, 33, right? We're not going to have those duplicates. So let's go ahead and print ages set, print ages set, run it. And down here, I'm going to move this up. See, we don't have a duplicate of 17. We don't have a duplicate of 33. And if you look, it's not really in the order that we have. It's actually kind of close, so I can see where you might confuse that, but it's not in any order. If I run this again, we're going to get a different order. Just pay attention. It's 18, 17, 55. So run it again. Well, let's stop it. Run it again. See, now we got 55, 26, 33. So again, order is not guaranteed. You can't have duplicates. So again, back to the question, why would you use a set? Well, it's because of performance. Again, like I said, the set has very fast insertion, very fast lookup, very fast deletion. And the reason being is because in order for something to go into a set, it has to conform to hashable. Stick with me. I know as an absolute beginner talking about hashable and hash values and constant time lookup, that is getting a little bit excessive. I understand that, but I can explain it pretty simply. Now, conforming to hashable is a requirement to go into a set. Now, luckily, the basic types that come with Swift that we talked about, string, int, boolean, double, float, those all automatically conform to hashable. So this is really only going to come into play when you're creating your own types, right? Like we created our person type. Remember that example? Person with the name Sean. That's not going to conform to hashable unless we actually implement that ourselves. So until you're building your own custom objects and custom types, pretty much everything is going to conform to hashable. So don't worry about that too much. Again, as long as you're using int, double, bool, string, which is what you'll be using most of the time. Now, by conforming to hashable, what that means is that it just has a hash value that is an identifier. Again, I'm putting this super simply. Think of a hash value as like a direct pointer to that location. Let me do an example to illustrate that. So here, back in our code, we can do the contains function here. So we can do ages set dot contains, right? And you can see the member is an int, right? Because this is a set of ints. So I want to see if it contains a certain number. So by doing 17, it can look right for 17. That's constant time lookup. Whereas, array also has a contains function. However, what an array has to do, and this is why a set is faster, an array would have to check the whole array. So if I was looking for 17 in the array of ages up here on line 3, what the array does is it's going to check here. It'd be like 18. Nope, that's not 17. It'll check 33. Nope. Okay, it'll check 55. It'll check 17. Okay, cool. Now, in an array of 8 items, no big deal. But you can imagine, if you're storing data, you can have an array of, 1,000, 2,000, a lot of numbers, items. So that's where the performance comes in, where, again, the array has to look through the entire array until it finds the number. Whereas a set, because of the hash value, can go right to that number. And that's called constant time lookup. Basically what that means is the time to look it up will stay the same no matter how big the collection gets, right? So if our set, it has 1 million items in it, the time to find 17 is going to be the same exact time as if our set had 10 items in it. Whereas the array is different, right? If the array has 10 items, okay, that's going to happen pretty quick. It only has to check 10 items. If the array has 1 million items, now it's not going to be as quick because it has to check through 1 million items. So hopefully you're starting to see the performance of a set. But again, it's a trade-off, right? A set gets that performance because they don't guarantee an order and they can't have duplicates. So that's the trade-off. They trade those features for performance. Whereas an array, you can't have duplicates. It's always going to be in the same order, but it's a little less performant. And that's actually a good analogy for programming in general. You'll find as you go throughout your career when you're making decisions on what to use, it's all about managing the trade-offs, right? Every approach in implementation has pros and cons, and it's all about choosing the right tool for the right job based on those pros and cons. So let's run this, and you should see it'll print true here over on the right. Yep, true, because it does contain 17. Now, if I want to say, does it contain 100, which we know it doesn't, or 101, my finger slipped, it'll come back and print false, because it does not have 100 in there. So that's how you can see if your set contains a value. Now let's talk about inserting a value into our set. If you remember on our array, we use .append, and that tacked it on to the end of it because it keeps the order the same. However, sets don't have an append, right? We just insert it into the set. It's kind of like throwing it into a bucket. Like, we don't care about the order, mix it up, who cares? We're just throwing it into that bucket. And again, that's the whole, very fast insertion or deletion. I don't have to pick where exactly I want to put it. We're just putting it in the bucket with everything else. And to do that, you can do ages set.insert new member. And you can see let's insert that 101 that we put up there. And because the code, runs down the line here, let's cut this and put this up here. So that way we're inserting 101 into our set, and then we're going to check to see if it contains it. And now you can see down in the printout, I got confused because we didn't have a 101 down here in the printout. That's because I printed it before we added it. Again, the order you put things in matters. So hopefully that's another little bonus lesson that I didn't intend on. But now we're going to print ages set down here. Now 101 should pop up in the set. There it is. So it got inserted. And then let's check our contains 101. That is true. So again, to reiterate, the main differences between sets and arrays, even though they're very similar because they're a collection of items, is that sets are unordered, arrays are ordered. Arrays can have duplicates, sets can't have duplicates, and sets have faster, insertion, removal, lookups because of the hash value requirement. And again, it gets that performance boost because of the trade-off of no duplicate values and not having to worry about order. So that wraps up the basics of a set. On to the next collection type, and that is dictionaries. Our third collection type that we're going to discuss is a dictionary. And just like a set and an array, it is a collection of items, except this collection of items has labels, kind of, right? They're called key value pairs. And if you think about a dictionary, like what the title is, right? In a dictionary, you have the word and then you have the definition, right? So think of the word as being the key and the definition as being the value in the key value pair. Let's dive into some code for an example. Now again, here we are, blank playground. Go ahead and create that for yourself. But we're going to create a dictionary called devices. So let devices, and our dictionary is going to be of type, and you'll see how we declare it here. It's going to be a type string because the string is going to be the key and the value is also going to be a string. This could be an int, or it could be whatever you want, a bool, depending on what type of dictionary. But because I'm having the names of my devices, like my computer, my phone, this is also going to be a string. So you have to declare what type your value is. Your key is almost always going to be a string. It's kind of the standard. Now, there's some situations where maybe not, but 99% of the time, your key and the key value pair is going to be a string. So that is going to equal, right now, there's going to be an empty dictionary. So you do the square brackets and then the colon in the middle, because again, the colon separates the key and the value, right? The key is on the left of the colon, values on the right of the colon. So let's put some values in here. And as you can imagine, if I listed out 5 values, this is starting to look weird. So we're going to go ahead and put this on next lines here. So for the first key, let's do, what is my phone? And the value of the phone is going to be iPhone X. Yes, I call it an X and I still have the X. I'm waiting to upgrade. And then these are comma separated. So now the next key is, I don't know, let's say my laptop. The laptop, and then you shouldn't have a space after the key. This is a little style preference. So laptop colon, and that is a 2016 MacBook Pro. And then we can do, you know, what is my tablet? I'm only gonna do 4 of these. Tablet and colon, so that's the key, and the values is the 2018 iPad Pro. And then we'll do desktop, right? So these are, I'll kind of put this into context here once I'm done typing this. So desktop, and colon is a 2017 iMac Pro. Okay, so these are my devices. Whoopsie, expected a comma separator. I'm getting that error. I always forget to do this. These need to be comma separated. So this is my dictionary. And like I said, it's a key value pair. So you can see the key, phone, laptop, tablet, desktop, and then the value is whatever the value is. Now to put this into context, let's say we had a developer object. We're going to get into classes and objects later, but you can imagine like an object. Say the object is developer. Well, your developer has a name, maybe your developer has a job title, and then your developer may have a dictionary of devices attached to it. So you know what devices your developer has. Again, that'll all make sense when we get into the classes and objects part of the course, but that's a little preview. You can kind of get your mind going in that direction. Now to access values in our dictionary, we need to look it up through the key. So let's do devices, and in the square brackets, you just pass in the key of what you want. So let's say we want our laptop. So if I run this, we'll see on the right over here, see 2016 MacBook Pro, because I accessed the laptop. So by passing in the key, I can get the value. This is also constant time lookup. So this is a benefit of dictionaries. They're very fast because you have the constant time lookup similar to the set. And the way that works is we know the key, so we go directly to that key and get the value, right? Like an array, we don't have to look through all the values to find what we're looking for. Like we know the exact location of what we're looking for. And that location is based on this key, right? So just to prove this here, let's do phone. What kind of phone do I have? Run it. Over here on the right, iPhone X. Not iPhone 10, iPhone X. So that is a basic example of using dictionaries. Again, it's a good way to store a collection of information with essentially labels on it using the key value pair. Again, back to our real world example, if we have our developer object, right? A developer would have a name. That name would be a string. Developer would have a job title. That job title is probably a string. A developer would also have devices, but except devices is going to be a dictionary. So we can see, oh, the phone is the iPhone, the laptop is the MacBook Pro, etc. So that's the basics of dictionaries. On to the next video. All right, on to one of the most important topics, and that is functions. Think of functions as like a compartmentalized set of instructions that you can reuse throughout your code base. And they can range from very simple one-line functions to pretty complex multi-line functions. Let me show you a real-world example, and then we'll dive into some basic code examples. So here on the screen, you see an example from my take-home project app in a viewDidLoad. We haven't gotten to that yet, but viewDidLoad gets called when a screen of your app gets loaded. So essentially what's going on here is this is a list of commands as to what's going on this screen. As you can see here, it's, configure view controller, configure search controller, configure collection view, get the list of followers based on this username, and then we're going to configure the data source. So you can see those are all functions that are being called. But that's just where we're actually using the functions. That's not where we defined the function. Let me show you one of these functions definitions. Here's where we actually wrote the function configure view controller. And you can see in this function, again, it's a compartmentalized set of instructions, right? So how we're configuring our view controller is you can see we're setting the background color to system background. That's just white or black based on dark mode. We're configuring our navigation controller to show large titles. I understand a lot of this is probably a different language to you, but I'm just showing you an example. We're creating an add button. If you ever used an app that has like a little plus button at the top, That's what we're adding here. And then we're putting that add button into our bar button. I'll show you a picture of the screen here to show you what's actually going on. But the point is, you can see, you can have all your logic inside this function where it's defined, and then now you can use configure view controller wherever you want in your code. Here we happen to use it, in view did load. When our screen first views, that's how we're configuring the view controller, and you can see we're calling it in view did load. So again, to reinforce that, it is a compartmentalized, reusable chunk of code, right? So you can see how we define it and then how we use it once it's defined. All right, so that was a real example from an actual app, so don't worry if a lot of that went over your head. We're going to dive into some basic examples that will hopefully connect the dots for you. All right, so let's start off super simple. In order to declare a function, you have to put the keyword func in front of it, short for function. So func, and let's say print instructor's name, right? So what you do here, you have the func here, you have the name of the function, again, print instructor's name. Now the name of the function should always be a verb, right? It shouldn't be a noun. Like you wouldn't want to do just instructor's name, right? That's a noun. Because a function does something, you want it to be a verb. So it should always sound like it's doing something. So print instructor's name, that's a verb, it's doing something. And then all functions need to have these open and closed parentheses at the end. This is where potential parameters come into play. More on that in a future example. For now, we don't have any parameters. And then you do an open curly brace and a closed curly brace. This defines the scope of a function. So the scope of the function is basically everything that's inside this function. And what's inside this function is what's going to be between these two curly braces. In this super basic example, we're just going to do print and put a string in there, Sean Allen, right? Now just defining this function doesn't automatically run it, right? I'm going to run my playground, nothing happens. You have to call your functions. Remember, just like the example I showed you, we defined the function and then we used it. So when you define it, you're just setting it up, right? You got to actually use it. So we need to call print instructor's name. Right? So you can see there's my function. So now when I run it, this is actually going to get called. So that means print will actually execute, right? You have to call your function in order for all the code you put in there to execute. So run it. Now you see Sean Allen in the lower left. So that's the super basic example. There's no parameters. There's no return types. We're going to build on this to show you that. So let's delete this for now. And let's modify our function so it takes in a parameter. Now, like I said, a parameter goes inside these parentheses. So, right, we hard-coded Sean Allen. So anytime we called print instructor's name, it's always going to be Sean Allen. What if we wanted to pass in a name? That way our function could be flexible and reusable. We have to tell it what name to print out. So here we can do, let's get rid of name here in the function. And now we need to label our parameter. So let's call it name. And it's going to take in a string. So let me explain what's going on here. So again, we have the keyword func to define our function. We have the name of it, print instructors, and then name is the label of our parameter. And the parameter it takes in is going to be a string. You have to give it a type, right? A name is not an int. It's not a Boolean. It's a string, right? So that's the type we're going to pass in. So now instead of printing Sean Allen and telling it what to print, we're just going to say print name, right? Because name was the label of the parameter. So we're going to print whatever name we put in. And the name we put in is going to be down here when we call it. So now let's do print instructor's name. Now it's saying, okay, in order to call this function, you have to tell me what name to use. So now, and like I said, I can't put in 5, right? It's going to tell me, hey, no, we expect a string because, again, we declared the type up here as a string. Again, this is Swift's type safety in action. So now we have to pass in a string. So now let's do Joe. Right? No, it's not Sean anymore, just to show you that it's not going to print Sean. So now when I run it down here, you're going to see it printed Joe. So now our function up here is not always programmed to say Sean Allen. Now it can say whatever name we tell it to be. And that's in general how you want your functions to be. You want your functions to be super generic so they can be reused in any situation, right? You can imagine we could have print instructor's name for Sean, for Joe. We could have 5 functions printing out specific names, but now we just have one function where we tell it what name to print out. And again, name is the parameter, and you have to give it a type of a string. And then again, down here in the scope, so this parameter label gets used within the scope of the function. So within the scope of this function, we have it here. So name is going to equal whatever we pass in. As you can see, it prints Joe. So we're printing stuff, and that's all fine and good to just illustrate the point. But let's use an actual kind of real situation, because oftentimes you're not just going to print stuff, you're going to need things. So let's create another function called add, and then we're going to do first number, and then that is an int. Remember, every parameter you have to give a type. So we're going to add two ints together. So add first number int, and then we're going to go to second number. Let's talk about this in a second. So second number is int. And here that is going to return. So this arrow means it's going to return something. It is going to return an int. And let me explain that. And then we do open and closed. So let me run through this function signature. That's what this is called, by the way. This is called a function signature. You're going to see Xcode's yelling at me. I'm missing a return in a function expected to return an int. So what return means is it's going to do calculations and it's going to spit out a value, right? So you can kind of see what's going on here. We're going to pass in a first number, pass in a second number. We're going to write code to add them together, and then we're going to spit out the value. This is kind of like a little factory, right? It takes in two numbers, spits out the sum. So when you want a function to return, you create this arrow, which is the hyphen and then a greater than sign. And then you have to give it a type that you're going to return, right? Like I can't return a string here because an int plus an int's not going to equal a string. And what Xcode's telling me again is that I don't have the return function. So it's just letting me know that I have to specify that, hey, I'm returning something. So I'm going to return 5 right now. Just to get rid of the error, we're not actually going to return 5 because we got to do some math first. So in here, what we can do is let sum equals first number, because I'm passing in a number, plus second number. And then we want to return the sum, right? We want to spit out the sum outside of our factory here. Now, let me talk about this to right here. This is called an argument label. This helps your function be more readable. Let me show you. So now when I call this function down here, I can do add, and you can see first number to second number. So it just reads nicely. So if I wanted to add 18 to 126, right? Add first number 18 to 126. It's more readable, and that's the benefit of Swift. Is it's nice to read, right? If you've seen other languages, it can be brutal. And what that did up here was the argument label is what shows up. This is called the call site. Wherever you use your function, right? Remember, you define your function's logic, and then you have to use your function. Wherever you use your function is called the call site. So what your argument label does is helps your call site be more readable. So again, argument label gets used at the call site. This is the parameter label. The parameter label gets used within the scope, right? So that's why we use second number down here. And if I run this, we should see, yep, 144 over here on the right. Let me just kind of illustrate that. Let's get rid of this argument label. And this one won't read too bad, but you can see add first number, 14, 100, right? Add first number, second number. It doesn't read as well as add first number to, and then a number, right? So again, this makes sense, but it's not as human readable. And in Swift, you strive for that human readability in your code. Trust me, when you read a code base that reads nicely, you're really going to appreciate it. So anytime you see two words up here, remember the first one is the argument label, which gets used at the call site. Let me get rid of this here. Add first number to, 55 to 114. So the argument label gets used at the call site. The parameter label, which is the second one, gets used within the scope. I know this is very confusing for beginners starting out. They'll see multiple labels up here. They don't know what that label means. And again, I could have named this anything I want. I could have named this giraffe, right? If I wanted to. And then now here at the call site, I'm going to get add first number int giraffe int. Obviously that makes no sense, but I'm just illustrating that it doesn't have to be like to, for, or on, because that's often what they are, but they can be whatever you want to name them, so it makes sense. All right, let's go back to to here. I don't want to use ridiculous examples to confuse you too much, but hopefully that drove the point home. 77 to 55, right? Run it. So you can see, let's run through this function again just to show you all the parts to, again, really drive the point home. Function add, that's the function name. Our first parameter is first number, and you may notice that this one only has one label while this one has two. By default, your parameter name will be used as your argument label at the call site if you don't explicitly use one. Like right here, we're using two, so that's why it shows up. But we didn't use an argument label, so the parameter name shows up down here at the call site. But anyway, parameter label, you have to pass in a type. Remember, we're adding two ints together, passing in another type for the second parameter, and then we're returning, because again, remember, this is a factory. It's taking in two numbers, spitting out another number. This is returning is what it spits out. It returns an int, so you can see, here's where we do our basic arithmetic, first number plus second number, and then you have to return the sum. So again, this is you actually spitting out what you want to spit out of this function. And let me finish this video by showing you a relatively complex function. Again, I do not expect you to get this, but I want to show you kind of what it's like in the real world and how you can use functions inside of functions. So here on the screen, this is what happens when you actually tap the add button, right? We're adding a user to the favorites. So you can see we're calling show loading view. That is another function. So you can use functions inside of functions, right? Because when we add button tap, we want to show the loading view, and then we're getting the user's info. This is a network call. This is hitting up a server, downloading the information. Again, don't worry about that. But you can see then we dismiss loading view, which is another function. And then we're using a switch statement on results, more on that in a bit, which has more functions in it, add user to favorites, present alert on main thread. That's another function. So again, don't be intimidated by this. I just kind of wanted to show it to you like in action, in the real world, so you have an idea of how all this can come together. Again, don't be intimidated. But anyway, on to the next video. On to another very important and very common thing, and that is the if-else statement. And this is basic logic that almost all computer programming is kind of based around. And essentially, you probably kind of get it already in your head. It's a simple statement that says, if this happens, do that, or do this, right? It's just the basic logic, If user is logged in, send them to the home screen, else send them to the login screen, right? So if they're not logged in, they go to the login screen. If they are logged in, they go to the home screen. So again, it's a basic if this, then that. So let's dive into some code to create our example. Now, if statements are based on what's called a conditional. A conditional is something that is either true or false. Let's create our conditional right now. So it's going to be a Boolean. Hopefully you put that together. So var is dark mode on equals true. So if is dark mode on equals true. And actually don't have to type that. I'm just leaving it there so you can really see what's going on. And then we create the scope of our if statement with our curly braces here. Now, equals means is it equal to? More on operators in a later video, but one equal sign means we're setting the value, right? So this equal sign means we're setting is dark mode equal to true. Two equal signs means we're checking it. Like we're checking if dark mode on equals true. So again, more on the operators later, but that was a little sneak peek. So if is dark mode on equals true, then we want to print that's how it should be, right? So now when I run this, it's going to print that out because it's going to evaluate, it's going to check, is dark mode on equals true? And up here on line 3, it is. Now, we don't have an else statement. So what's going to happen if all you have is just the if, is if this checks out to be false, so let's make this false, run it again, you'll see nothing happens. So what happens in this code is it goes down, it checks, is dark mode on? And if it's false, it just continues on. It doesn't go into the scope here. If it's true, then it goes into the scope and prints this out. So that's why if I flip this back to true, now it's going to go into that scope and it will print out, that's how it should be. So there you go. Now, like I was saying, is I don't have to type this. Xcode is smart enough to, if you have a Boolean like that, it defaults to true. Like it defaults the first check to be true. But I wanted to type that out so you could actually see what's going on. But from here on out, we'll just do is dark mode on. Because again, it reads better, right? If is dark mode on, and that's why you title your Booleans. Again, this is all just like best practice and convention. That's why you want to title your Booleans something like that, like is dark mode on, is user logged in, etc. So that's the very basic level of an if statement, but now let's add the case where we want to do something different if dark mode is false. So that's where you do else and then give you another scope. Now we want to print you are a psycho. just kidding, not really. Anyway, so now let's run it. Dark mode is true, so we're still going to get that's how it should be. Now if I flip dark mode to false, it's going to go into the else statement and print you are a psycho. There you go. You should use dark mode. So that's the basic if-else statement based on a very specific Boolean that we already have. But it doesn't always have to be a specific Boolean. Let's do something real quick. So var my high score equals 555. Var your high score equals 444, right? Those are your scores. You can do, again, it just has to evaluate to true or false. Again, that's the conditional. So you can do if my high score is greater than your high score, let's print I win. Else print you win. So you can see I don't have like a specific is dark mode on Boolean here. I kind of created my own just to check, whose high score is higher, right? So mine is higher right now. So I'm going to print, that's funny. I didn't even mean to do that. You are a psycho, I win. Yeah, anyway, that made me laugh. And you can see if I make mine lower, do 111, you're still going to be a psycho, but you're going to win. You are a psycho, you win. Let's actually comment this out because it's kind of funny. So you can see the main point I wanted to show there was it doesn't have to be a specific Boolean. Anything that evaluates to true or false. Again, if something is greater than or less than, that's going to be true or false. You can use that as the conditional in your if statement. Now we've covered the if statement if there's only two paths, right? True or false. Well, what if there's multiple paths? Let's change this back to high score and let's get rid of this and we can start over from here. So we just have a high score. So we can check multiple paths. Like let's say we want different levels to this, right? For example, if high score is greater than 500, we want to print you're the best, and then we can do else if, and we can do else if you have multiple paths, and this is where you put the next conditional. Else if high score greater than 250, print your average. And then the final one, we can do multiple else ifs. We can do else if high score greater than 100, print you need improvement. And then else is always the final one. You don't need else if for the final one. So else kind of catches all the other cases. So basically anything less than 100, we're just going to print, yikes. So you can see there's multiple paths that we're going here. So let's run it. So what does our high score of 111 get us? You need improvement. So how this evaluates, right? It checks first. It says, is the high score greater than 500? Well, the answer is no. So then it goes into this next else if statement. And then it checks again. Is high score greater than 250? No. So then it keeps falling down until it finds one that is true. So else if high score is greater than 100, yep, that's the one. Then it goes into here and prints you need improvement. So let's try another one. Let's give me a high score of 1,000. Well, again, it's going to check this first one. Oh, we're greater than 1,000. Okay, we're done. Go in here, print you're the best, and we're done. We're not going to evaluate anything else. Give me a big fat 0 here. And again, it's going to go through all these. It's not greater than 500. It's not greater than 250. It's not greater than 100. So it falls into this else statement, which again is kind of like the catch-all if none of these equal true. And then we just print yikes. So those are some basic if statements. Again, that is foundational knowledge. You're going to use if statements all over the place. So hopefully you understood it. And again, it's basically if this, then that. All right, let's talk about the basic for loop. And there's really two very common ways that you use them. One is to iterate over a collection. Remember, a collection is like an array, a set, a dictionary. And another is to do something a certain number of times. Now, the best way to explain that is to actually show you. So let's dive in. So to use our for loop, the first way of iterating over a collection, we need a collection. So let's create an array. Let all stars equal, and this is going to be the LeBron's team all-stars from this year's game. So LeBron James is the first one. I'm just going to use the last names here as well. So Davis for Anthony Davis, and Harden, and Doncic, D-O-N-C-I-C, and who is the fifth? Leonard, Kawhi Leonard. O-N-A-R-D. So again, that's the starting five for LeBron's side of the NBA All-Star team if you don't have that context, and it's just their last names. So this is our collection that we're going to use to iterate over. So here's how you write a for loop. It's best for me to actually write it out, and then I'll explain it. So for player in All-Stars, and then here's the scope, right? The open and close curly braces creates our scope. So what do we want to do in there is we want to print player. Now let me explain this before I run it. So what this is saying is for every player in the All-Stars array, I want to print their name. That's what it's saying. So if I run this, again, you can see we printed out James, Davis, Harden, Doncic, Leonard. Again, it printed out in the order, because remember, arrays are ordered, that they're in. Now, this player can be anything I want, right? I named it player because that makes the most sense. And again, back to Swift being readable, the way you write your code, you say for player in All-Stars, like kind of makes sense, right? You may also see a lot of people do like for item in whatever the name of the array is. And then, you want to print each item. That's fine, but item is generic. Like I said, I think player makes more sense. But you could, again, if you wanted to call this a giraffe, you could. I don't know why I keep going back to this giraffe example. But my point is, because I know I've gotten a lot of confusion before from other beginners, is they thought this had to be named something specifically. And I want to really emphasize that this needs to be named whatever you want to name it so it makes the most sense for your code base. And in this code base, player makes the most sense. So again, for whatever item, and then this is every item. So what happens is this executes, as you can see over here, 5 times. So that's the beauty of Playgrounds. It'll tell you how many times it executes. So what happens is the first time it goes through, player is equal to James, right? Makes sense. So the first time through, it prints James. The second time through, now player is equal to Davis because we're iterating through the array. We're going through each item. And the third time through, Harden is the player. So that's how this for loop actually works. And you can even expand on this basic one. Like let's say we wanted to check for Harden on the specific case. So we can say where player is equal to Harden, right? So again, the way this reads, I know this is kind of a really long line of code. For player in all stars, so this means this for loop is going to, again, go through this entire list, but it's going to check where the player is equal to Harden. So the only time this code is going to execute is when it's looking through this array, if player is equal to Harden, then it is going to print the player. So the only player I should print is Harden because that's the only time it shows up. So let's run it. Print Harden. So that's a little bit more of an advanced for loop, but it's such an easy example to show. And I just like how readable Swift's for loops are, right? For player in all stars where player is equal to Harden. Like that makes sense even to non-programmers, I would think. So again, that's a little bit more of an advanced one. The basic for loop is to just iterate over it like I explained earlier. Now that's the first example of iterating over an existing collection, in our case it was an array, and executing some code based on that. The second common example is doing something a certain number of times. So let's do that real quick. Let's get rid of this print statement here because I don't want to print that out for confusion. So what I can do is I can do for I in, and here we can create a range. So 0 less than 25. And let me explain ranges real quick. So that it makes sense. So you can do a range. So I could have done 0 to 25, but that's going to give me 26 numbers. Because again, this is how many times it happens. And so if we're starting at 0, that is actually going to run 26 times because the ... will go from start to finish. If you do ... and then the arrow like up until, that will go 0 through 24, which gives me 25 times, right? If we're counting 0. We're gonna have more on ranges later in the course, but sneak peek. It's really tough to like do things in perfect order. It's almost impossible, right? To like, make sure I didn't show this section until I showed ranges, right? Because it's just a tangled web. Anyway, so what this is gonna do is print I. And actually, let me minimize this real quick. You see the error I'm getting from Xcode? Immutable value of I was never used. Consider replacing it with an underscore. Remember that. We're going to do that in the next example. But similar to player up here, I can name this I whatever I want. It's just very common in best practice and convention that whenever you're dealing with a count of something, I is pretty much the standard here. But again, you can name that whatever you think makes the most sense. So when I print I, what's going to happen is it's going to print 0 through 24. Because I is what I'm printing, and I is the counter essentially of how many times it's executing. Remember this for loop up here in the NBA All-Stars that executed 5 times because All-Stars only has 5 objects in it. Well, here I'm saying run this for loop 25 times. That's what this 0 through 1 less than 25 is. So when I print I, it's going to print 0 through 24. So that's the 25 items. So let's run it. So there you can see there's 0 through 24. So again, the for loop executed 25 times, printing I each time. Again, that's how many times it's iterating through it. And then over here on the right, you can see it went through 25 times. Now that's the super basic example. Let's actually do something that you might want to do in real life. So let's say we wanted to create an array of random numbers. So var random ints. And again, we want to declare that as an empty array of int. Remember I said you're going to be doing empty arrays a lot, like it's pretty common. So this is an example of when we're using that. Let me just uncomment this to that yellow error is annoying me. So here we have our empty array of random ints. Well, here in our for loop, we want to put a random number in there each time. So let's do let random number equals, and this is something we don't actually cover in the course, but int has a random function on it, int.random. and we want to pass in the range. We want to do 0, 1, 2, 3, 100. So remember that back to ranges. So I want any number between 0 and 100 to go into my random integers array, and it's going to run 25 times. So our random int array is going to be filled with 25 numbers. So, but first we need to append back to our array thing. So random ints, which is this array up here on line 9, dot append. The new element I want to append is the random number we just created up here on line 12. So random number. And then you see here, immutable value I was never used. This is what I pointed out a few minutes ago. So basically, if you're not using the name variable, it's recommended to just use underscore. So if you see underscore, that means there would have been some variable name there, but we're not using it, so it just avoids confusion. So again, this is going to execute 25 times. Each time it goes through, I'm creating a random number. That's what's going on here, 0 through 100. And then now that I have that random number in my variable here, or constant, right? It's a let. Now I take my random ints array and I append this random number that I created right here. So what's going to happen if I come down here and print random ints, we should see an array of 25 random numbers. And again, this is something you may actually want to do for an app. Well, after it prints off my starting 5, you can see 50, 84, 48, right? They're just random numbers, 0 through 100, thrown into an array. And we did that real quick using this for loop to create 25 random numbers and then throw them into that array. So that's the basic for loops. Now, the topic of loops, there are more, like a while loop, a repeat while loop. Don't worry about those now because those are more niche. I mean, they're used, but this for loop is used 95% of the time. So this is the basic fundamentals I want to show, but I will put a link in the description to my video on all the types of loops if you want further information on that. All right, see you in the next video. Next up, we have enums. Some people call it enum. It's because it's short for enumeration. I call it enum. But anyway, an enum is a group of values that are related. Here on the screen, you can see some common examples are, directions, north, east, south, west, right? That all makes sense to be grouped together. Sometimes you have, days of the week, Monday, Tuesday, Wednesday, etc., right? That makes sense to be grouped together. We're going to use an example based on phones, right? iPhone, Google Pixel, etc. So the basics of an enum, again, are a group of values that are related that you put together in an enum. And in this video, I'm going to show you some examples of how to use them so you can see how powerful they are. So here in the brand new playground, again, go ahead and create that on your own. To create an enum, you just do enum and then you call it something. So we're going to call this phone and then open bracket, close bracket to, create the scope. Now each enum has a case. So you do case iPhone 11 Pro, case iPhone SE, case, Pixel. I don't even know what number the Pixel's on. I think 4. We don't mess with that, right? And then case Nokia. Now, I listed all these out with, which each line has a case. You can, however, I'm going to cut this so I can paste it back. You can do iPhone SE. You can do comma separated to put it all on one line if you like. I'm not going to type out the rest of the phones, but I could have listed those out all on one line. So if you see an enum declared like that, it's the same exact thing as having them all out on one line like this. Now I'm going to leave it like this because as somebody just learning enums, I think it's better to visualize it as like separate cases when they're all on separate lines. So now I'm going to show you 2 examples of using enums and you can see how they can make your code a lot more readable and clean. And to do that, we're going to create a function. So that function is going to be func get Sean's opinion and then on. And remember, this is the argument label. And then our parameter label is going to be phone. And then the type this takes in, remember we talked about, it could be an int or a string. Well, now we have our own custom one called a phone up here on line 3. So this is going to take in a phone. That's what we're going to pass in. Again, open and close parentheses to declare the scope of our function. So again, our function is get Sean's opinion on phone, and we're going to pass in one of these phones. You're going to see how we use this in a second. Actually, you know what? Let's go ahead and write it right now. So in order to use this, I can do get Sean's opinion on phone. Again, back to how readable Swift can be. And the phone I pass in is one of these cases. And you can see I can do dot, and then I can get the options in my enum, right? It can either be an iPhone 11 Pro, iPhone SE, Nokia, Pixel, etc. But I only get these 4 options because, again, I've declared this enum with only 4 cases. And that's why enums are a group of, related values. Again, back to the other examples, north, east, west, south for directions, or days of the week, etc. So we want to pass in the iPhone 11 Pro. Now, if I run this, nothing's going to happen, right? Because we haven't written any code in our function right here. So let's go ahead and do that. And I know I keep going back to this, but I just love how you can make Swift so readable. Like, right, get Sean's opinion on iPhone 11 Pro. I mean, that's like a human readable sentence, right? It's not even like code. Anyway, I digress. Back to writing the logic in this function. So we're going to build upon a previous video where we did if statements, right? Because there's multiple paths, right? We talked about how you can do the if else and then else if to go down multiple paths. But we have 4 paths to take care of: iPhone 11 Pro, iPhone SE, Nokia, and Pixel, to get Sean's opinion on each one. So let's do that. So if phone equals dot iPhone 11 Pro, we want to do this. And now, again, real quick, this phone is what I named my parameter. So phone here. So now I have access to this phone within the scope of my function, right? So that's how we're accessing it here. And I like to go back and reinforce and repeat stuff from previous videos just to really drive the point home. Because like I said, I know in the original videos for some of these, I went over them very quickly, but that's because we're going to use them throughout the course. And again, you're going to get plenty of chances to really utilize these skills. So if phone is equal to, remember the double equal sign, iPhone 11 Pro, we want to print, this will be my next phone. It won't be because I'll wait for the iPhone 12, but whatever. And then now multiple paths with the if statement. This is review from a previous video. So else if phone equals dot iPhone SE, we want to print out something else. And I'm just going to copy and paste this print statement because I don't have to type it every time. And now we will say, I dislike this phone size. It makes design hard. That little small phone size. But so some of you who have maybe seen Swift before, maybe saying like, this should be a switch statement. You are correct, but I don't want to get ahead of myself, and I want to reinforce the if, else if, get practice at that. In the next video, we're going to talk about switch statements and how you can clean this up. More on that in a bit. All right, so the next path we want to handle is else if phone equals dot pixel, and I'm going to say hardware is great. Android is, ew, don't like Android. And then else, again, can be the catch-all, and put the print statement in there. And this is like that old Nokia phone, right? Is can't be broken. Classic, that old Nokia phone. So again, how this function reads is it's going to get Sean's opinion. We're going to pass in a phone using the enum, right? And the enum makes it nice and clean. So I can just do dot iPhone 11 Pro. Remember before we were passing in strings and we had to type in the string? The danger with a string is that if you make one small typo, your code's going to break, right? And so if you're typing strings all over the place, that's very fragile. We call it stringly typed. That's not an official Swift term. That's kind of just some slang. But you want to avoid stringly typed stuff because, again, one small typo, everything breaks. So putting things like this in enum will make it so you get the autocomplete, like you saw here, to where I can just type in, or I get the autocomplete here. So we're gonna try the Nokia first. So let's run this, and we're passing in Nokia here on the phone thing, and then you see it goes through our if statement like we did in the previous video, and it determines that I'm on the Nokia phone, so it prints out can't be broken, classic. And let's just test one more. Let's pass in the iPhone SE, run it again. And you see, I dislike this phone size. It makes design hard. So you can see, again, the power of enums really cleans up your code, makes it nice and readable, and it's also easy to understand, right? You have your list of phones up here. Now, if you look at this function, it's kind of sloppy, kind of messy. Like I said, we can fix it with a switch statement, but we can actually make it even cleaner by using raw values on our enum. So up here in our enum, we can actually give it a type. So right now it's just generic, right? A phone. We can say a phone has a string raw value. So now I can say the case for the iPhone 11 Pro is going to equal, and it's because we declared it a string, I can take this string and put it up here. So now the case of iPhone 11 Pro has a raw value attached to it, and that raw value is a string, and that string is this will be my next phone. So let's go ahead and do that for the rest of them, and you'll see how it's going to clean up our function very nice here. So do this, maybe, copy equals maybe, copy equals Command V. Okay, cool. So all of our strings are up there as and if you don't know me, you'll know I like to do this. I like to line up my equal signs to make my code look neat. You don't have to do that. That's a stylistic choice. But now this kind of if-else statement, and I'm teaching you this as a beginner because it is foundational knowledge. But the honest truth is, if you find yourself with a very long if statement, if-else, 99% of the time, there's going to be a better way to write that. And that's kind of what I'm illustrating right here. So usually if you see this is kind of sloppy code. It's usually the sign of a beginner. So we're going to clean this up. So instead of having the if statement and checking, we know we have a phone, right? So I can just do print and then phone dot raw value. Enums have a raw value, right? So this right here, remember we said this phone has a raw value that is a string. And then on each of the cases, I gave each case a string for a raw value. So now instead of having that crazy if statement down here, we can just print phone.raw value and it's going to print the string. So to prove that, let's not do the iPhone SE, let's do the Pixel and run it. Hardware is great, Android is ew. So you can see because Pixel was passed in, this is essentially saying pixel.raw value, and pixel.raw value is hardware is great, Android is ew. So that's basic enums. Enums are actually a pretty deep topic. There's a lot more you can do with enums, associated values. Enums can have functions attached to them. Again, beginner course. This is how you're going to use enums the vast majority of the time. So just start here with enums. Again, we have the different cases. You can pass in the case of the function. It makes the code nice and clean and very readable. And then also we can assign raw values to them. So again, when we pass in the case iPhone 11 Pro, it has that string attached to it. And then we can access that string by saying phone.raw value, as you saw in this latest example. All right, that wraps up enums. We're going to move on to switch statements, which don't have to be paired with enums, but oftentimes they are. So let's move on to that video. In the last video, we had that sloppy big if-else statement. In this video, we're going to talk about switch statements and how we can clean those up. And like I mentioned last time, switch statements are often paired with an enum, but they don't always have to be. Let's dive into an example to show you how to use this. So here we are in our previous playground. Hopefully this looks familiar. It's from the last video where we have our enum of a phone. I took away the raw values because we're going to showcase the switch statements. What we're going to do here is replace this if else stuff with a switch statement. So what I'm going to do so I can copy and paste to save all the typing time is make some space down here. And we're going to create our switch here. I'm going to end up deleting that bottom part later, but I just wanted to make space so you can see it. So to create a switch statement, and again, it's basically just a cleaner way to write this and it's more readable. So let's do that. So switch, and then I'll hit enter to get the basic switch statement. We'll kind of go through this. So the value here is we want to switch off of our phone. We want to handle all the cases of a phone. So our value is the phone. That's what we're going to check and evaluate. So now what a switch statement does, as you can see, is it handles the various cases. Again, this is why it's often paired with an enum, as you see here. We're going to do the next example where it's not paired with an enum, but again, this is common. So the first case, iPhone, and because we are switching off of a phone, that's our value, it knows that it is of type phone, and it knows that it has 4 cases. So that's why it is giving me these cases here. So we're going to do iPhone 11 Pro first. And now the code, this is what you want to execute whenever it's this case. So in this case, we're going to copy and paste this print statement because it's the same thing. Paste that there. And that's our case for iPhone 11 Pro. And then now we just add the rest of the cases. So case .iPhone SE, colon at the end. On the next line, we put the code. Again, we're just going to copy and paste this string. So like I said, it's very, very similar to this big long if-else statement. It's just cleaner and more readable, as you're going to see. So case.pixel, colon, and then on the next line is whatever code you want to execute. Now we're only doing a print statement, but this could be a whole batch of code. And then our last case is the .Nokia, colon, next line, and then the last print statement here. Now with switch statements, they have to handle every single case. Now when you declare your own enum, I only have 4 cases, right? So there's not some random case. So we don't need this default because we have all cases handled. You'll see an error sometimes that says, switch must be exhaustive. That means you have to handle all cases. So in this case, we have 4 explicit phones, but let's say we didn't. Actually, you know what? I'm going to save that for the next example because we're actually not going to be able to exhaust all cases. So put a pin in that. But let's put these up here. Let's delete some space here. Again, you can see that the if statement and the switch are very similar, but look how cleaner the switch is. You can be like, hey, when it's iPhone 11 Pro, do this. When it's the iPhone SE, do this. When it's the Pixel, do this. Whereas it's just a little more cleaner. So we're going to delete that, clean this up a bit, and then now we'll run it. So get Sean's opinion on iPhone SE. What it does is it passes in the phone. The switch statement says, okay, I got a phone. Which one is it? It's the iPhone SE. Okay, cool. Execute this code in the iPhone SE case, which in this case is a print statement that says, I dislike this phone size. It makes design hard. So that's how you use a switch statement paired with an enum. Let's talk about a switch statement on its own without an enum. All right, so down here, we're going to create like a little ranking system if you were, ranking up in a video game or something. So let matchmaking rank equal, and we'll say 5,000 for now. So let's actually comment this out so we don't get any confusing print statements there. So that means we're not actually going to run that function. So let's create our function here to determine our matchmaking rank. So func determine player league, and then you can do from, again, this is the argument label, and then rank is the parameter label that we're actually going to use in the scope. And then the rank is going to be an int. That's what we're going to pass in, because that's what this is up here on line 28. That's an int. Get our open and close curly braces for the scope of our function. And now we do a switch statement based on the rank that we're passing in an int. Now here we're not paired with an enum, but we can still do switch. And we want to switch off of rank, which again is our parameter label that is an int. You can see it shows the type int. And we want to have various cases. So we do case 0. And return, we're going to put the code there. But you can see our error right here, that switch must be exhaustive. And then also case label and a switch should have at least one executable statement. So you have to have some code in there. So let's do print play the game to determine your league. So basically this is what happens when our matchmaking rank is 0, like we haven't played a game yet, right? So now we do case. Here's where ranges come into play as well. So from score 1 ... up into less than 50, that's our next case. Now we can do print you are in bronze league. And then continuing this, we can do case 50 ... up until 100. And let's just copy and paste this to save some time. Copy, paste, you are in silver, and you can see where this is going. I'm only going to do up to gold, and then the default case. We'll talk about that. So case 100 ... up until 200. Paste that. You are in gold league. So again, the way this switch works, and we'll get to this exhaustive in the default case in a second. We're passing in the rank, and then it's going to switch off the rank. If you are 0, you're going to say determine, play a game to determine your league. And then if your int falls in one of these ranges, again, we got a good review on how to use ranges, it'll print the appropriate message. Now, you'll notice it only goes up until 200. Well, the switch must be exhaustive, meaning it has to handle every possible case. So in order to do that, when you don't have like an enum that has a set number of cases, you do default. This is basically your catch-all. So the default, we're going to do print you are in a league of your own. You are too good. Meaning like you're above 200, right? Because we're handling everything else. Well, we're not handling negative numbers, actually. So maybe this is the wrong message. Let's play, you're in a league of your own. We don't know where you are. So let's test this out. Let's pass in a 45. That should put us in bronze. We actually have to call the function. Sometimes I forget to do that. So determine player league from matchmaking rank. Again, the readability of Swift. Determine player league from matchmaking rank. So good, so good. And our matchmaking rank is up here, and it's equal to 45. I just changed that. So we should go into bronze league. Let's run it to test it. Yep, you are in bronze league. One more test, or two more tests. Call it 150. That should put us in gold. And you can see if you're making a video game and you want to assign a player certain leagues, like you can do something like this. You are in gold league. Now let's test out our default case. So let's do 1 and a lot of zeros right there. I don't even know how, what is that, 10,000, 100,000? It says, you are in a league of your own. We don't know where you are. That's because it went into our default case, which was kind of our catch-all. And again, negative numbers, right? You wouldn't think matchmaking could have negative numbers, but this is kind of a point of programming is handling the edge cases, right? So run it again. It's going to say, again, you are in a league of your own. We don't know where you are because, again, it doesn't fall into any of our cases. So the default is the catch-all. So that's the basics of switch statement. And again, to put it super simply, if you just remember this, it's just a neater, cleaner way to write a big, long if, else, if statement, right? That we saw up here previously with this switch statement, right? This just looks a lot cleaner. It's more straightforward, easier to read. So utilize the switch statement if you see yourself having that big if, else, mess you got going on there. All right, on to the next video. Let's switch gears a little bit and talk about operators in Swift. Now, operators allow you to check, change, and combine values. That may sound a little complicated, but think about it like you're already familiar with the term, right? Operators are like math, addition, subtraction, multiplication, division. Think of them like that. And actually, that's the example we're going to start with is those basic math examples. But as you can see, there's many, many more operators, and hopefully you can see how useful they are after this video. All right, here I am in a blank playground. As always, feel free to create that yourself. Let's create two values here. So let value 1 equal, 55. Let value 2 equal 88. So now here we can do let sum equal value 1 plus value 2. All right, we're back to first grade. Simple addition with the plus symbol. All right, hopefully I don't have to drill that point home. Now that is the addition operator, and then now this operator. Well, let's actually run it so you can see the sum to check it. 143. Now we can do value 1 minus, again, very basic math, but we're going to run through this real quick. Now it's negative 33, right? 55 minus 88, negative 33. Checks out. And to do multiplication, you do the asterisk or shift 8 for the star. That is multiplication here. So I don't know what 55 times 88 is, but we're about to find out. 4,840. Now, that was all smooth sailing. Now's where it gets a little tricky because division here, we're going to do 55 divided by 88, which as you can tell, that should be less than 1. That should be a fraction. But watch what happens, and we'll explain this. So let's run this. So this is going to be 55 divided by 88. 0. That's not right. Here's why. So via type inference, these are ints. So a property of ints is int is always a whole number, and int can't be a fraction. So the way Swift handles ints when it's a fraction is it just literally cuts off the decimals, right? So this should normally be, let's do it, 55 divided by 88. This should be 0.625. So what it does is, like I said, it just drops the decimals. So that's going to be 0. Now, if this was 1.625, it would drop the decimals, so it would show up 1. Again, this is only when you're using ints versus ints, because an int is a whole number no matter what. And the key thing to remember, it doesn't round up, it doesn't round down, it just drops the decimal. So even if this was 1.9999999, it wouldn't be 2, it would be 1. Drops the decimals. So when you're dealing with ints, just remember that when it comes time to use division. So if you're using division and you want percentages, you have to make these floats or doubles, whichever one you choose. Now they have to be the same, right? I can't divide a double in a float, right? You're gonna see Xcode's gonna yell at me. Binary operator, the division sign, cannot be applied between operands of double and float. So when you're adding and subtracting, they have to be the same type. So if I go back and make this a double, now it's the same type. I'm not going to get that error. And then we get that 0.625 number that you saw me do in Spotlight. So again, math was simple up until we got to division. Key thing to remember, an int is always going to be a whole number, and it's not going to round up or down. It's just going to drop the decimals. So I bet that'll still get you in trouble, even though I kind of reiterated that. Happens to all of us. So those are some basic math operators. One more that is unique to programming, or at least I haven't seen it outside of programming, and that's the modulo operator. So to show you that, let's go back to ints here. So to do that, we're just going to get rid of the declared type. So this is automatically going to make those ints. Now, what this does is it's similar to division only because it deals with remainders, and the modulo operator is a percentage. So let's change these values to make a little bit more sense. So say value 1 is 100. So how many times does 88 go into 100 is what modulo says. And what it does is it gives you the remainder. So 88 goes into 100 one time, but it also has a remainder of 12, right? So because 100 minus 88 is 99. If you remember back to very early elementary school math, you would say 1 with a remainder of 12 is how many times 88 goes into 100. So let's run it, and the modulo here will equal 12, as you can see. So it's similar to division, except you're only getting the remainder, right? That's all it spits out. So now make it 1,000 and make this whatever 881. So it's going to go in 1 with a modulo of 119. So that's modulo, and again, that will give you the remainder of how many times one value goes into another. Now let's start talking about some equal signs. You know what? I'm just going to leave this up because we're already here. So, and I've mentioned this in a previous video, how one equal sign is considered an assignment operator, right? We're assigning 1,000 to value 1. We're assigning 881 to value 2. Here we're assigning, you know, sum. Apologies, sum was probably the wrong variable name for the, you know, multiplication and all that stuff. But sum is, we're assigning the modulo, which is 119, to the variable sum because of one equal sign, right? We've done this a lot. Now, compare that to two equal signs. That is where you're saying, is this equal to that? So we're going to basically say value 1 equals value 2. And right, those are not equal, as you can see on line 3 and 4. So if we run this, we're going to get a false, right? So that evaluates the false because they're not equal. Now let's make them equal and run that again. Now we get a true because they are equal. Let's get rid of this to avoid confusion. So before we use this in our if statement, right? So let's do that. If value 1 equals value 2, print they are equal. Run it, and there you go. We've done this before. Hopefully this is a review. They are equal, so it happens. Now let's talk about the bang operator, or an exclamation point. So instead of equals, if we put an exclamation point here, what this is saying is if value 1 is not equal to value 2, now we want to say they are not equal, but this isn't going to run. This isn't going to execute because they are equal, right? 1,000 equals 1,000, so we're going to see nothing print down here. But if we change this, you know, 1,010, it is going to go into the scope. They are not equal because this means not equal to. Now another version of the bang here is back to our var is dark mode on equals true, right? That equals true. So another thing we can do here is, remember we did this before, value is dark mode on. This is going to evaluate to true. Automatically, I don't have to do equals true here, right? Xcode is smart enough to handle the Boolean that it defaults to true. So now if I put the bang operator in front of that, that is now saying if dark mode is on equals false. So we're going to say it's so bright in here because is dark mode on equals false. That means it's not dark mode. So it's so bright. So is dark mode equals true. So that means this is not going to execute, right? Because we want this to be false. That's what the bang operator tells us. Now when I flip this to false, now it should execute because it is false. So it's so bright in here. Okay, that's what's known as the bang operator. It's meant for it like not being equal to. Now, one thing we're going to get to in a future video is optionals. And one way to unwrap optionals is to put an exclamation point at the end, right? So don't get too confused. The bang operator at the beginning is what flips the conditional, you know, or the Boolean to false. The bang operator at the end is for unwrapping optionals. So just want to clear that up. And again, more on unwrapping optionals later. Now let's go back to the example we had of value 1 equals value 2. And then also real quick while we're here, you can do the greater than. If value 1 is greater than value 2, do something. You can do less than. You can also do the, you know, less than or equal to. That works. Or you can also do the greater than or equal to. Whoops. Right, and that means if it's bigger or equal to, then execute. Again, those are basic math principles that hopefully you learned when you were just a child. But now let's talk about the or and operator, and I'll show you that. So this is a way to combine conditionals, right? So we would say if value 1 is equal to value 2, and you can do and is dark mode on equals true. So this is a way to handle like two scenarios. So we only want to execute this code say dark mode yes and they are equal. So this code is only going to execute if both of these conditions equal true. So if these are equal values and is dark mode on has to be true. See if it is dark mode on is false right now. So if we run it, it's not going to execute anything as you see down here because is dark mode on is false. Again, both, when you use the and, they both have to be true. So run it. And now it's, oops, I forgot to make these equal. 1, 2. So there you go. See, now you see they both have to execute as I accidentally showed. Now they're both true. So dark mode, yes, and they are equal. So that is the and operator, and that is by 2 of the ampersands. Now the or operator is another thing you use in your if statements or conditionals as 2 vertical pipes, and that means either one of these can be true, right? And was they both had to be true, or just any one or the other. It doesn't matter if it's only is dark mode on is true, and this is not true. Like just one of them has to satisfy the condition and the code will execute. So here's a good example. We're going to make these not equal, but is dark mode on is true and the code will still execute. So you see down here, yep, dark mode, yes, and they are equal. Now 2 more things before we finish up the operators. Let's get rid of this code here. Let's just get rid of this altogether. You know what? Let's just really clean up here. Let's do var counter equals 0. Right, there's my int that equals 0. Now we can increment this. We can do counter plus equals 1. So that is basically adding 1 to whatever the current value of the counter is. So let's run it. You can see over here on the right, we get the 1. And let's say if this was, 41. Now our counter is going to be 42, as you can see. So we're just incrementing the number by 1. You can also decrement, which is subtract, by doing minus equals. So if you ever want to like keep a count of something, counter is very common. If like every time a user does an action, you want to increase the count, you do, whatever it is, plus equals 1, that'll increment it by 1. And again, you can also decrement by minus equals 1 to lower the count by 1. And then lastly, you can use the plus icon here to add strings and arrays together. So let's say let greeting equal hello, and let name equal Sean. So I can do print, and then the message is greeting plus name. So we're adding 2 strings together, and you'll see the greeting that gets printed will be, hello, Sean. I forgot to add a space, right? So you just put it together, little unintentional lesson here. So I can do a space there, that's the space, and then another plus, so you can like really keep adding these together. So now it's going to be the greeting plus space plus name. And then you'll see now it's going to equal hello, Sean. So again, you can add strings together. You can even do it with arrays. Say we have let ages young equal, 3, 6, 9. Someone finish it. And then we do let ages old equal, 99, 4, oh, that's not old, 67, whatever, that's it. And then now we can do let all ages equal ages young plus ages old. And what's going to happen is ages old will get added onto the end of ages young, and it'll be one combined array. So if we do print, and we want to print all ages, let's run that. We're going to get the greeting, and you see 369 and then 9967. So again, these operators can be used in many different ways. We only scratched the surface here, but again, basics course. So hopefully you understood those basic operators. As always, if you have questions, leave it in the comments or hit us up in the Slack channel. See you in the next video. All right, we're on to our first tricky topic, and a topic that hangs up a lot of beginner developers, and that is optionals. Declaring something as an optional means you're giving it the ability to handle the absence of value. Before I give you the basic explanation, let's dive right into this playground to talk about an example that we saw in a previous video. So here in this new playground, you can create your new playground and copy this if you like. Remember we had our ages array, and let's say we want to get the oldest age of all of our students, right? That was all in the array. So let oldest age equal, and remember we did this. We did ages dot last. Do you remember this? And I said this question mark means ages dot last is an optional. And the reason it's an optional, remember, because ages could be an empty array, and there's no last item in an empty array, right? So that's why it can either be a value, which in our case would be 71, as that's the oldest age in there, or it could be nil, the absence of value, if the array is empty. So that's what the optional does, is it gives you the ability to either handle the value or handle nil. So let me hit return here and let's run it, and you'll see we get the 71 over here, right? That is our oldest age, 71, because we sorted the array here, ages.sort. Now let me give that empty array example. I'll do Command X so I don't have to type them again. And then I have to give this a type now because it's an empty array and it needs to know. So we put int in the square brackets to let it know it's an array of ints. And now when we run it, oldest age is going to be nil. As you can see here on the right, it is nil, and that is the absence of value. So Swift giving you that flexibility to handle both is great. However, what I just said is you as a developer have to handle both cases. So when you write your code, you have to do what we call unwrapping the optional to see if it's either nil or if it's a value. You write the code to handle it when it's a value, and then you also write the code to handle it when it's a nil case. And that's what we're going to talk about in this video, is what the optional is and how to unwrap them. So the most common way to describe what an optional is imagine an optional is like a box. You don't know what's in that box. It's a closed box, right? The box could have the value in it, in this case the number 71, or it could have nil. You don't know what's in the box until you unwrap it. That's unwrapping the optional. Now, the reason you have to unwrap it and handle both cases, like we mentioned, is because if you just use that box and expect it to have a value, and then it ends up having a nil, your app's not going to behave correctly, or in most cases, it'll probably even crash because you didn't handle the nil properly. And remember I said that, take a second, remember, most of your crashes when you're building an app will come from you not handling a nil case properly, right? You'll run a program, it'll expect a value, that value will be nil, and your app will crash. You're going to see that 1,000 times throughout your career. Very common. So again, in this video, we're going to talk about how to properly unwrap and handle the nil cases. So let's work with this oldest age variable and unwrap it. So the first way, there's actually 4 ways we're going to do this. We'll comment this. If let is one way. Nil, I'm going to spell this wrong for sure. Coalescing. I for sure spelled that wrong probably. And then there's the guard statement. And then there's the dangerous, we'll explain why, force unwrap. We'll get back to that in a second. But I wanted to list those out real quick, and I'll leave the comments in the playground. Hopefully you put them in the playground as well, so you can have the names of how to do this. So the first one is if let. I'm actually going to delete that so we can write it from scratch. So you do if let oldest age, and we're giving it the name here, equals ages.last. And this is the optional. So here's how this reads. Well, actually, let me give it the open and close curly brace because we have to set the scope of our if let statement. So we're saying is if ages.last has a value, right? If it's not nil, if we open up that box and it actually has the value in it, then give that value a name oldest aged. We're storing it in a variable. And now we have access to that variable within this scope. So now we would do print the oldest age is, and then here's what's called string interpolation. You do the / and then the parentheses, and then here you can pass in the variable oldest age because that's an int, right? An int is not a string. So in order to put something into a string like an int, you have to use string interpolation. And then now we do the else statement for if it's nil. Now we want to do print there is no oldest age. You must have no students, meaning the array is empty. So again, right now the array is empty. Let me run through this again before I run it. So what we're saying here is if ages.last has a value, right? Then assign it to this variable called oldest age. And now we can only use oldest age within this scope right here. And that's where we're using it to say the oldest age is blank. And then the else statement fires off if it's nil. So if it's nil, meaning there's no value, you would say there is no oldest age, you must have no students. And in real life, when something's nil, this is where you'll probably pop up like an error message or something. But you don't always have to just do print statements. So right now the array is empty. So let's run it and we should go into our nil case, right? Yep, there is no oldest age. You must have no students. Let me do a Command V here to paste back in our ages. And now let's run it because now we do ages.last is going to have a value. It's going to be 71. Now let's run it. And the oldest age is 71. So again, we unwrap the optional. Depending on what's in the box, a value or nil, we handle both cases properly. So that's the if let statement. That's kind of a little bit verbose. No coalescing is a little bit simpler. So here we can do let oldest age equal ages.last. And here is where we can give it a default value. So we can do question mark, and then now we have to give it an int. So here's where, in this case, it might not be useful because I have to give it an age. So let's say, I want to do 999, which is obviously not a real age, I think, unless you're Yoda. So what this is saying here is, okay, let's create this variable, oldest age. If ages.last has a value, right, we unwrap the optional. If there's a value in there, cool, that's what oldest age is. If there's nil, we give it a default value of, in this case, 999. Now to use a guard statement, we have to be in a function because a guard statement has to return, has to have an early exit. That will make sense when I actually show it to you. So let's write a quick function, func get oldest age, right? And here we can do guard let oldest age equal ages dot last. Looking very familiar so far. And here's where it differs. Else, and then you have to return if it's nil. So what guard does is it gives you what's called an early exit if it is nil. And oftentimes you may see this on one line like that, just to avoid confusion. I'll put it on this second line just so you know that that's what's happening, because when I explain it here. And a big benefit of using a guard statement is oftentimes it can clean up code. I like to call it like a line in the sand, like you're drawing a line here, because what happens is nothing will get executed after this guard statement. Like let's say you had a bunch of, a lot of code down here in this function. Well, basically what the guard statement does is, if ages.last has a value, go ahead and assign it to oldest age. And if not, return. Like stop the function. That's why I call it a line in the sand. Nothing happens below. Like nothing will happen below this return if oldest age is nil. Because oftentimes when you're writing functions, like if the value you're trying to use a lot is nil, like you don't want to execute all that code because you need that value. So again, this gives you an early exit out of the function should you get nil. And then oftentimes in this return block here, this is where you would show like an error alert saying, hey, we didn't get the value, sorry. But for now, we're just returning, getting out of the function. But the difference between if let and guard let is, remember, if let gave you access to this oldest age variable only within this scope right here. So you can imagine if you're checking for the optional in the beginning, now you have, a lot of code down here. It can get real. It's called the pyramid of doom, where you have like if let, if, and it just becomes a giant like pyramid of code. So guard avoids that again by checking for the value up front. And if it doesn't have it, you get out. If it does have it, now you have access to oldest age in the entire scope of the function, not just the scope if let was just its own scope. You have it in the entire scope of the function. Now we'll do print and some string, and we'll do some string interpolation again. Oldest age is the oldest age. So 71 is the oldest age. But like I said, I have access to this oldest age variable just in the scope of my function. It doesn't go into the pyramid. So guard is nice, one for the early exit, and it cleans up your code, avoids what we call the pyramid of doom. So now let's run this real quick, and you'll see it now prints off. Yep, I forgot to call the function, as always. Always happens. It's going to happen to you a ton of time too. Get oldest age right there. So now that we execute get oldest age, now we print 71 is the oldest age. That's this print statement right here. So now finally the force unwrap. This is super dangerous because it's like the cheat code, the easy way out. So you would just do let oldest age equal ages.last and just put an exclamation point on there, go the bang. And basically what this is saying, and this is why this is a little bit reckless and very frowned upon. Some developers will say, never force unwrap an optional in any of the code bases, right? I'm of the opinion that sometimes it makes sense, but definitely by far, like the rule of thumb is to not use force unwrapping. Because what that does is, remember that box that either has the value or a nil? You're basically saying, I don't care what's in this box, use it. And this is where your crashes are going to come, guaranteed, because you're going to say, don't even look in the box. I don't care. Just use it. And then it's going to try to use it and it's going to be nil and crash. Like this line right here, this force unwrapping, trust me, you will see hundreds, thousands of errors in your code based on trying to do this. And again, because what happens is you say, use the box. I don't care what's in it. Nil is in it. And then crash, 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 crash. So, but that is a way to unwrap optionals and you will see it used. Like it's not going to be that uncommon, but just know that there's danger when doing it. So that's some basic ways to handle an optional. And again, just to really drive the point home, an optional in Swift gives you the ability to handle the absence of value, which again is like that box. It can either have the value in it or it can be nil, and you have to handle both cases gracefully. Or if you force unwrap, you say, I don't care, just use it. And that'll lead to some trouble. But anyway, as always, questions in the comments or in the Slack. Check you in the next video. In this video, I want to introduce you to the concept of self. Now, to be honest, maybe getting a little ahead of ourselves right now, but we're going to be using this throughout the rest of the course. So I wanted to at least introduce this to you, and then we'll have time to reinforce it as it comes up later on in the course. And the concept of self is actually pretty simple, but I remember when I was just learning, like, I didn't fully understand it because I never took the time to stop and like learn what it was. So that's what we're going to do now. The first example of self is going to be in the initializer for our custom button here, GF button. We're going to get into classes and subclasses in the next couple of videos, but let's just focus on the self aspect of this here. So here in the init, you can see self.init, self.background color, self.title. What self refers to is exactly what it says. It's self. So self here is basically the GF button, this current instance of the GF button. So the reason we have to use self in this initializer is because we're saying, hey, make the self.background color means the background color of our GF button equal to background color. And we had to put self here because it doesn't know, like, here's the background color we're passing in as a parameter. What's the same name as this background color? So we need to say, hey, set self's background color equal to the background color that we passed in. And again, self refers to the instance of the GF button. Let's do another example. Here in the favorites list VC, which again up on the screen is just that table view. Well, when you create a table view, which again we'll do later in the course, you have to set delegates, a delegate and a data source. So you can see the table view.delegate equals self. Table view.data source equals self. And again, self refers to what class we're in. We're in our favorites list VC, which is a subclass of GF data loading VC, which is actually a subclass of UI view controller. Again, more on classes and inheritance in the future video. We're focusing on self right now. So again, basically this saying table view.delegate equals our instance of favorites list VC, which is the screen that shows the table view. That basically connects the table view to the view controller. So that's what self means. Self is, again, whatever instance of the class you're in, favorites list VC. So again, just an introduction to the concept, because like I said, I never fully understood what self meant when I was first starting out. And it's so simple when you think about it. Again, just to drive the point home, self is just kind of a shorthand way of saying this current instance of the object or the class that I'm in. So in this case, it's the favorites list VC is what self is equal to. All right, so you got a little tease of like classes and subclasses. Let's go ahead and talk about that in the next video. So let's talk about those classes. A class at a high level is an object. It's one of the building blocks of object-oriented programming. And it's an object that can have properties and functions attached to it. Let's actually build one to show you what I'm talking about. We're going to use a version of that developer example we had before. So to declare a class, you type class, and then let's call it developer. And now we need to give it properties. Remember the developer had var name, which is of type string. It had var job title, which was another string. And let's say var years experience, which was going to be an int. So our developer class has these properties, right? Name, job title, years of experience. Now you can see Xcode is yelling at me, class developer has no initializers. So when you build a class, you have to tell Xcode how to initialize that class. Initializing a class basically means creating a new one. So we would want to do something like this, right? Let Sean equal developer. And remember before we were using like some initializers that you saw in that other developer example? Well, we don't have those initializers yet. We have to create that because we have to tell Xcode how to create a developer. Like how do we build that? So to do that, we have to create our initializer like this. Init, and the parameters it takes in, it's going to take in a name, and that is of type string. And the parameters it takes in are what you want to initialize the values to, right? So we want to pass in a name. We want to pass in a job title. We want to pass in number of years experience. So here you go. Job title, and that is a string. And now years exp, which is a integer, right? So now this function, just like before, we have to set the values that we pass into this initializer, right? Because we're going to pass in a string for the name. We're going to pass in a string for the job title. We're going to pass in, an int for the year's experience. We have to set those to our developers properties. So here we need self.name. Remember before how we have to distinguish between this name that we're passing in and the developer's name that we're setting. So what we're saying right here is, hey, take this name that we pass in this string and set it equal to my developer's self. We're essentially naming our developer, like our developer's being born and we're giving it a name. So very similar stuff here. Self.jobTitle equals job title, and self.years exp equals years exp. And again, the ones in white are the whatever we're passing in. The ones in green are the actual developer's properties that we're setting. I know I've repeated myself a bunch there, but this confuses a lot of people. So I really wanted to, again, drive that point home. I know I've said that 1,000 times too. I like to line up my equal signs. I think it looks nice. You don't have to do that. So anyway, we have our initializer now. So now when we create our Sean object here, so let Sean equal developer, and we do our open parentheses, you see we get our initializer that auto-completed. Like that's what we just created up there on line 8. So if I hit return, now it'll tell me, okay, pass in a string. So my name is Sean, my job title is iOS engineer, years of experience, 5. Right? So now I have this object called Sean that is a developer. And now Sean has all these properties. So, right, so if I do, let's see, Sean.name, Sean.jobtitle, Sean.yearsexp, and then I run it, you're going to see over here on the right, look, the value of Sean.name is Sean. The value of Sean.jobtitle is iOS engineer. Sean.yearsexperience, 5. So that's the basic way to set up a class with an initializer. Now there are other ways to initialize classes. Another common one is you just want an empty version of it where name, job title, years experience are nil. So in order to do that, we need to make these optional, our properties up here. So string is optional, job title optional, years experience optional. By making these optional, we can create an initializer that just creates an empty developer. Let me show you what I'm talking about. Let me get rid of my Sean one right here. And we have to create this init here that is the empty one. So init, no parameters, we're not passing anything in. And then we can do open and close curly braces because we're not doing anything. We're just initializing the empty developer here. So that allows us to do something like this. So let Sean equal developer and then just an empty initializer. So now let's go down here. And if I do Sean.name, you see it's an optional. Sean.jobtitle, see that question mark, makes it an optional. Sean.years experience. By the way, this dot is called dot syntax, just a little side note. So now when I run it, you're gonna see all these values are nil. There you go, nil, 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 nil. But because I've made them optional, it allows me the flexibility to create an empty one, and then I can add those properties later, right? With this initializer, all those properties were set when the object was created. By doing it this way, with just the empty initializer, we're creating the object that is empty essentially, right? All the values are nil, but we can change those later, right? I can do Sean.name equals, Joe. Sean.jobtitle equals coder. Years experience equals, 10. So now when I run it, it's going to have value now. So if I open up this developer here, you can see it'll say name, Joe, job title, coder, years experience, 10. So by initializing the empty one, you can set the values later if you need that flexibility in your code. Now, aside from properties, classes can also have functions and functionality. So here in our developer class, let me just get rid of this here. We'll create a function, func speak name, and that gives us some functionality here, and we can do print name, which is our name up here on line 4 that we assign it. Now again, if we assign it with an empty initializer, it's going to be nil. So if we create our Sean developer again, I'm just, again, reinforcement here, let Sean equal developer, and see now we have the empty initializer or the ones that we want to pass in. We actually want to pass in values here. So again, Sean, job title, coder just for short, and then 2 years experience. So now I can also do Sean.speak name, right? I put some functionality onto this class. And if I run this, you're going to see it's going to print, well, optional Sean. Again, that's because name up here is an optional. Force unwrap. Again, remember that's the dangerous one, but we're just doing this real quick. I don't want to go through the full unwrapping. Now it just prints Sean. And what I just said, I don't want to go through the full unwrapping. That is often why you see people force unwrap. It's a shortcut. It's kind of the lazy way, but I wanted to illustrate that to show that that's how force unwraps usually end up in code bases. Anyway, little side note. But that is the basics of creating a object, a class. Now, a struct is another kind of object that we're going to get into in another video. But the reason I'm mentioning that is because I want to show you this in action. Here is our user object, again, from my GitHub followers course. And as you can see, that is a struct, but you can see all the properties, very similar to what we did with our class. But the reason I'm showing you this is because I want to show you the screen right next to it to show you this object in action and how it's actually being used. So let's look at this, right? Like our user has a login. That's what we're using for this name right here. Our user has an avatar URL. That's what we're using to pull down the image for the avatar that you see here. We have name, location, bio, right? How many public repos, public gists, etc. So you can see, here's an example of an object, and you can see how we're using that object to populate this screen with that data. So we'll leave it at that, showing it in action. Let's talk about inheritance, because that's a big thing with classes. And then we'll move on to structs and reference types and value types. As I mentioned at the very end of the last video, classes can be subclassed, which means they also have inheritance. So that subclass inherits all the properties and functionality of the parent class. Let's walk through some examples and I'll show you. What we're looking at here is a custom button that's been created, again, in the GitHub followers course. Here's what the button looks like on screen. It's the green one at the bottom. You see how it has rounded corners, big bold text. Well, here, that is a class called GF button, and you can see it is a subclass of UI button. That's what this : UI button means. So again, this reads as the class is a GF button, which is a subclass of UI button. So what that means for us is we're getting all the features and functionality of iOS's built-in UI button, right? By default, iOS has a button, has all the push, the tap functionality, all the stuff you would expect a button to do. iOS has done for you. What we're doing is we're subclassing that into a GF button. So we get all the features of the superclass, or the parent class, you'll hear it called, this UI button. However, we want to give it our own little custom feel and functionality. So down here, that's what we're doing. You can see I have a configure function where I'm giving it a corner radius, which is the rounded corners of 10. You can see I'm making the font a specific font type. I'm setting the title color to white, and then we're doing some auto layout stuff, more on that in a bit. And then you can see we gave it a function as well, where I can call on my GF button, I can call set background color and title. So this allows me to quickly change the background color to whatever I want, and also pass in a title, whether I want it to be get followers or, go to the repo, whatever I want the button title to be, I can quickly pass that in. So we're going to build on our developer example to show it to you in action, but I wanted to show you like kind of a real life one. Again, the GF button is a subclass of a UI button, and you'll see that a lot in UIKit. For example, when you make your own view controllers, let's go to that there, screens, our search VC. So our search view controller, which again, is this what you see on the screen, our initial screen here, is a subclass of UI view controller. So again, we're getting all of iOS's built-in UI view controller, which is the screen. We're just making it our own. So again, that's subclassing and inheritance. Let's build our own version. We're going to create a subclass of our developer, but let's clean up a little bit from our previous playground here. Let's get rid of, no, we'll keep speak name. We'll get rid of this initializer because we're not going to initialize an empty one. I'm just making space here. Okay, so down here, we're going to create another class called iOS developer, which is a subclass of developer. Right? So what we're saying here is give me all this functionality up here and properties. So my iOS developer is automatically going to have a name, a job title, years experience. My iOS developer is going to be able to speak its name. Like it's going to get that automatically. However, we want to add like our own special things to our an iOS developer. So maybe we want to add a property called favorite framework, and that would be a string. It's optional. And then maybe we want to speak that favorite framework. So func speak favorite framework, and that will do print favorite framework. And then you see it isn't optional. So it could potentially print nil or it could print the framework. And you know what? Let's actually do a little exercise in the unwrapping. Remember I said last time I'm going to be lazy and force unwrap it? Let's actually do it for real to show you an example here. So what we could do here is if let favorite framework, this is us creating a new variable, equals favorite framework. You see this is the optional one because it says that. Then we do this. We will print, I'm going to cut and paste this here, print favorite framework, and you see it switched to white. So that means it's this one. Remember, because this is the variable we set that we can use within scope. So what we're saying here by unwrapping that optional is if favorite framework, if this favorite framework has a value, set it equal to this variable, favorite framework, and then now use this favorite framework to print that. Else, so this is when it's nil, we're going to print I don't have a favorite framework. Right, so that is how you should actually unwrap the optional there. So now you can kind of see why sometimes developers get lazy. They don't want to go through that. Don't be lazy. So now let's create Sean as an iOS developer. So let's do that. Let Sean equal iOS developer, and now the initializer. See, I get the initializer, right? We didn't set an initializer in our iOS developer subclass. I get this initializer up here from developer because, again, we're inheriting all those features and functionality. That's the power of inheritance. So iOS developer, let's do this here. Name is Sean. Job title, iOS engineer. Years experience, 5. But now we will do Sean dot, well, no, let's do Sean dot speak favorite framework. We haven't set the favorite framework yet. So let's run this, and it should say, I don't have a favorite framework. That's because up here, favorite framework was nil, because we never set it. Again, that's the power of being an optional. You can see why it's called optional, because you have the option to have it or like not have that value. So now let's actually give it a value. So Sean, well, above speak your favorite framework, so we set it and then speak it. So Sean dot favorite framework equals, this is a string, right? We'll call it ARKit. That's not really true. I don't have experience with ARKit yet, but hey, it's the first one I thought of. So now when we run it, Sean, speak favorite framework, you see it speaks ARKit. And again, back up here to reinforce the concept of optionals, because we unwrapped the optional and it had a value, we used it here and we printed that favorite framework. Now you'll notice up here, speak name. Our iOS developer has this speak name functionality, but we can also do what's called override. So this is where, so override speak name. So now this is where you can say like, yes, I know I have this speak name functionality as a subclass, but I want to do something a little different with that speak name. So this is where you override that speak name function. So you can do, I would do like print, let's do name. And again, we're going to force unwrap because we're going to be lazy. And we'll say dash iOS name dash job title. So we want our speak name to also speak our job title because we're proud to be an iOS developer or iOS engineer there. And again, we're going to force unwrap that too. Dangerous, living dangerously. So now down here, we've created Sean as an iOS developer. If I do Sean dot speak name, it's not, before, if I wouldn't have overrid that function, it would have just spoke my name. But because we overrode the function and gave it new functionality, now we're going to speak the name dash job title. So down here, Sean dash iOS engineer down here, as you can see. So that is overriding your inheritance, right? It's kind of like if your mom and dad gave you blue eyes and you're like, no, I don't want blue eyes, I want brown eyes, and you override it, is essentially what you're doing here. So again, to reiterate, our iOS developer class is a subclass of developer, and because of inheritance, we inherit all this functionality of our developer to kind of create our own little custom version of it. Again, back to the GF button example here. We get all the functionality of a regular UI button. We just added our own little flair to it, giving it the rounded corners and different font, etc. So again, that is the concept of inheritance. The concept of a struct is actually quite similar to that of a class in that it's an object. It can have properties, it can have functions. Remember, we talked about that user struct from the GitHub followers course. You see that has properties as well. Now, structs are a lot more lightweight and performant than classes. And the reason why is because they are value types. Let's talk about the difference between reference types, which classes are reference types, and value types, structs are value types. So a reference type, which again is classes, point to a specific set of data, whereas structs kind of copy that data and it's its own instance when you create a new one. I understand. That probably didn't make any sense. I have a good analogy that I've used that will hopefully clear it up for you. So think of a reference type, which again is a class, like a Google Sheet that you're sharing with people, right? Like I create a Google Sheet, I put my information in it, and I share it with you. Now, if you change that sheet, you're also changing what I see as well, right? You're changing the initial source of truth. Whereas a value type, or is like a struct, is like if I were to create an Excel spreadsheet and then, I would create it, I would save it, and then I would email it to you like it's 2003, and then you would open up that Excel spreadsheet and use it as your own. So the difference here is that on your Excel spreadsheet, no matter what you do to it, what kind of crazy changes you make, I still have my Excel spreadsheet. Like, your changes aren't affecting me, right? I made a copy of my spreadsheet, sent it to you, and now it's your own thing. It's your own instance of your spreadsheet. Well, again, that is like structs and value types. Let's walk through some basic code to show you the difference. All right, so we're back here at our good old developer class, and you can see I've created Sean. I've left that up there. So again, this is class, this is the reference type, and I have Sean. And let's change this to var because we're going to be changing Sean around a bit, as you'll see here. So remember, let is a constant, can't be changed. Var is a variable, can be changed. So I have Sean. Now let's say I want to do var Joe equals Sean. So now Joe is still referencing Sean. So if I did joe.name, and we'll scroll up a bit so you can see it and run it, it's going to be Sean because I'm referencing that. And then let's say I change this name. Say I do joe.name equals, and then we say Joe, right? That would make sense. So we're going to run this. You see now the name over here changes to Joe, as you can see. And now watch when I do Sean.name. It's going to be Joe. So run that. Now Sean.name, as you can see here, is Joe. Just print it out right there. So Sean's name, even though I put it into a variable called Joe, and then I changed Joe.name, well, again, the reference all points to the same underlying data. So I changed Sean, even though I think I was changing Joe. So, right, so Sean.name now equals Joe. So that is a reference type or a class. Again, you're pointing to the same underlying data. It's the equivalent of it being a Google Sheet. Any changes you make are all going to change the same source of truth. That is reference types. So now let's talk about value types here. So scroll up to the top. Very simple. We just changed this to a struct. So now this is a value type. One interesting thing with structs though, and this is another kind of benefit, is you get what's called a member-wise initializer. So with a class, we had to create our initializer here. So I can actually get rid of this, and Xcode and Swift are smart enough to know that it's going to give me this initializer, quote unquote, for free, which is called a member-wise initializer. Here, I'm going to prove it. So if I can do var Sean equals developer, which is now a struct, and you see I get this what's called a member-wise initializer for free because it knows that, hey, put all these into an initializer. All right, so I'm just going to Command Z back to the to get the type there. Okay, so now we have our developer named Sean, which is now a struct. So now we're creating copies here. So let's do var Joe equals Sean. Now what this did is this just basically made a copy of Sean and assigned it to Joe. So if I do joe.name equals Joe, and I run it, we're going to get what we expect here. Joe's name, as you can see, is going to be Joe, iOS engineer, 5 years experience. Again, we expect that. We changed Joe. However, Sean's name is not going to change. So Sean.name, remember last time it changed it to Joe because we did a reference type. Well, Sean.name is still Sean. Again, just like the Excel spreadsheet example, when I created this Joe variable here of a developer, I basically created a copy of Sean and assigned it to Joe, but I did not do anything to the original Sean variable up here. Whereas again, the reference type was all pointing to the same data. We were changing that. So hopefully now you have an understanding of reference type versus value type. This is actually one of the most common job interview questions for your first iOS developer job. So if you're not quite sure, you didn't quite follow, again, hit up the comments, hit up the Slack channel. Happy to help, but this is 100% you're going to get asked this in a job interview if you decide to go that route. You can't avoid it. Again, reference type versus value type, key knowledge. Hope you learned it. Up next, let's talk about extensions real quick. So an extension is really cool. It's a way to add like custom functionality to an existing type. Let's do a string one, for example, here. So we can do extension string, and now we can give this string our own little functionality here. A common example that I've used on quite a few projects is to remove the white spaces in between a string. So func remove white space, and that will return a string, because what we're doing here is we're calling this on a string, as you'll see, and we're kind of mutating it and spitting out a new string. So we can return components separated by .white spaces, and then we can do .joined to bring them all together. So let's see this in action here. Don't worry if you didn't understand that code. That's just the example I'm using. Here's where like the lesson is right here. Let alpha bet equal, I'm not gonna do the whole alphabet, but say you had like A space B space C space D space E space F, right? And you got this string, you're like, no, I want them all together, right? I don't want them all spaced out. So right, we'll do this real quick just to show. Print alphabet, run it. You're gonna see down here in the console, right? It's all spaced out, A, B, C, D, E, F. Well, if you did print alphabet dot remove white space, which is what we just created up here on our string. So by giving it this extra functionality, we can do our string dot and then whatever our new functionality is. So we did our string alphabet dot remove white space, and now when I run it, they're all no spaces in between, as you can see down there. So again, the extension, and you can do this on ints, floats, bools, doubles, whatever extra functionality you want to give, you can create an extension for it and give it that functionality. So it's a nice way to customize the types to your needs in your app. Now, one thing is this will give every single string the ability in your app to do this, which in this case is probably fine, but let's talk about a button example. So here in this example, we have an extension on UI button, and you can see we have like a pulsate, and these are animations, pulsate, flash, shake. You see we wrote out some nice animations, rounded corners. So again, this is the point I want to illustrate, is that when you do an extension on a UI button versus subclassing a UI button, which we talked about earlier, so the extension, like I mentioned with the string, if I have this in my project and I do this in an extension, it is going to give every single UI button this pulsate, flash, all this functionality, every UI button. So that's what an extension does. It's project wide. Whereas a subclass, if I go back to that example here, right, we have a subclass called GF button. So only this subclass is going to get this functionality, right? The configure, the set background color. Now, this is just one subclass of a UI button, but you can imagine in a big app, you may have 3 or 4 different button types that you want to subclass. So when you subclass it, whatever functionality you give to those specific button types, like only they get it. However, the extension on the UI button, again, back to this here, gives it to every single button. So again, it's a matter of granularity, like how specific you want to be with your functionality, whether you subclass something or write an extension for it. So to reiterate, back to our string extension, again, we just added extra functionality to our string by removing the white space. And that's what you can do with extensions. Again, you can do them on classes, you can do them on types like ints, bool, string. It allows you a lot of customization, and they're pretty cool. I like them a lot. So as always, if you have any questions, hit up the Slack or the comments. See you in the next video. What is the Apple Developer Program, and do you need it? That's what we're going to dive into in this video. Here I am at developer.apple.com. This is a website you will visit frequently throughout your career, but I want to point it out in case you're not familiar with it. As you can see, you can get all kinds of information about what's going on from a developer's perspective from Apple, like SwiftUI, Mac Catalyst, the new frameworks, right? Augmented reality, machine learning. As you can see, I'm going to scroll down to the bottom here. Developer Program. This is what we're going to talk about here. So I'm going to click on that, and let's talk about what it is. So essentially, it's $99 a year. So it does come with a cost for you to be part of the Apple Developer Program. Let's talk about what you get for that. And that'll lead into, like, do you need to spend that money yet? So here, you can publish your apps worldwide. So in order to publish an app on the App Store, you have to have this developer account. And keep scrolling, the latest SDK betas. If you want access to all the betas that come out so you can work on the upcoming features before they're released to the public, you'll need this developer account so you can download the betas. For example, at WWDC, they'll announce, iOS 14 here in 2020. So you'll get access to iOS 14 3-ish months before the public does. That way you can build all the new features into your apps so it's ready by launch day. And also test your apps with TestFlight. So TestFlight is Apple's program. They actually acquired it. So you can beta test your app. As you can see, you can beta test it with up to 10,000 external users. So if you want access to TestFlight, you got to have this developer account, and then access to your app's analytics once you launch your app. So basically, to answer the question is, do you need to pay that $99 a year for this Apple developer account? Well, the answer is hopefully, eventually, yes, but right now, probably not. And why I say hopefully yes is because if you launch an app on the App Store, you're going to have that account. However, while you're building your app and just before you start beta testing, you can build it all without that account. But again, when you're ready to put it on test flight, you're going to need the account. That's how you beta test your app. If you need to mess with the new advanced SDKs, like the new betas, the upcoming features, you're going to have that account. So again, like I said, the answer is you probably don't need it right now, but hopefully you're going to need it eventually. And I'll link to this website in the description. Feel free to look around, but you see what's included. They list all kinds of stuff that you get here, how it works. They'll walk you through how to actually enroll into the program, what it does, etc. And obviously this enroll button right here, you can go ahead and enroll as an individual, or if you are like a company, you can enroll as an organization. I believe the organization fee is a lot more. I think last I checked, it was like $400 a year if you're enrolling as an organization, to where you can have multiple developers under you. Most likely you're going to enroll as an individual, but again, it'll walk you through the whole enrollment process. Again, start your enrollment. Link will be in the description. But to reiterate, Apple Developer Program, $99 a year. You probably don't need it right now, but if you want to release an app or access the betas, you're going to have to fork over that $99 a year to Apple. So if you have any questions about the developer program, again, comments, Slack channel. See you in the next video.